This series will be about converting existing Vue.js application that was built with using JavaScript to use TypeScript, and the application that we're going to integrate TypeScript into will be the following application that was developed in another playlist, and the link to that playlist will be in this video description. And by the way, this application is available online by the address that you can see on the screen, and also the link to the repository with the whole source code of this application will be in this video description. And we're going to start preparing our environment. So I already have this application opened in my editor, and just because development of this application has started nearly half a year ago, lots of npm dependencies in here are deprecated. So the first step we're going to do is to actually update each of these dependencies. First of all, we're going to update these couple of production dependencies. Let's open up the terminal, and in here run the command npm install, and package names we would like to update. And what's really important in here is to actually add a suffix at latest to every dependency name. This way npm will download latest version of these dependencies. After the installation process completes, let's open up package.json once again, and now I'm going to run the same command, but for all these development dependencies. So basically, I'm going to quickly list all those dependencies names and add suffix at latest to every dependency name. And please note that here I'm also using flag-d, which means that we are updating development dependencies. And right after the installation process completes, let's try to run Vite development server to make sure that our application actually works with updated dependencies. As you can see, after starting development server by running npm run dev, we see the address by which our application is available locally, and also we can see that the Vite version is 5, which is the latest one. And previously this application was using Vite version 3. So after opening this address in the browser, we can see our application. Looks like everything is working, and all these updated dependencies don't cause any issues. Next, to simplify the development process, as we're gonna be going through this course, I will install several helpful extensions that will simplify our development. First extension is called Vue Language Features, or Volar. This extension provides Vue support for VS Code, including syntax highlighting for .vue files. As we can see now, .vue file is properly highlighted. Next, to provide TypeScript support in Vue components, we're going to install another extension called TypeScript Vue plugin. Let's click install, and right after we're going to install another extension also related to TypeScript, which is Pretty TypeScript Errors. And what this extension is going to do is it will actually format TypeScript errors and make them more readable, because default TypeScript errors are not actually formatted in the best way. Later we're gonna see the effect of all these extensions as we're gonna be working on the code. And for now, let's just continue installing extensions. Since this project uses Tailwind CSS as a CSS framework, let's install Tailwind CSS IntelliSense extension, which provides support for Tailwind CSS inside VS Code. And now if we'll try to add Tailwind CSS class, we're gonna see such autocomplete with available Tailwind classes that we can select from. This is a very useful feature, especially to those who are not very familiar with Tailwind class names. Also, this project uses a tool called ESLint, which is a static quality checker. And in order to see all ESLint errors right inside VS Code, we can install extension called ESLint. Let's click install. And finally, to avoid formatting source files manually, we can install a formatter called Prettier that is going to do all the formatting for us. And later we're also going to define the keyboard shortcut, which is going to call this formatter and format files on demand. So all these extensions that have been just installed will be listed in the extensions.json file inside .vs Code folder, but this folder is currently ignored by Git. So let's open up .gitignore file and remove these two lines. And this way .vs Code folder with some specific settings and key bindings that we are going to define later will be available on GitHub. And the link to the repository of this project will be in the video description. And by the way, if you'd like to see how this application was developed step by step, there will also be a link to the playlist in this video description. In this lesson, we'll take time to apply some configurations as well as define a couple of keyboard shortcuts that are going to speed up our development. So first of all, I'm going to define keyboard shortcut to apply formatting to files. Let's try to break formatting in this view component and then execute the command in a command palette called format document. As we can see, since I don't have default formatter configured for this file type, VS Code asks me to configure it first. Or we can also specify formatter which we'd like to use by running command format document with, and in here we will see the list of all available formatters. And as you can see, after I have selected formatter, the file was formatted. Also, if we're gonna run the command format document with, and then choose this option configure default formatter, right here we can specify the formatter which is going to be used all the time for this file type. And the corresponding setting will be added to the default settings.json where all VS Code settings are configured. But I'm going to add these configurations in the local folder of VS Code just to commit all these settings to GitHub repository. So I'm going to create a file called settings.json, and right here let's add a setting to specify default formatter for some file types. First of all, I'm going to specify default formatter for file types JavaScript, and the formatter we're gonna use is prettier. So in here I need to specify identifier of the corresponding formatter, and then I'm gonna repeat the same setting to specify default formatter for a couple of other file types such as TypeScript files as well as view components. So once again, let's try to break formatting in this component and then run the command format document. And in this case, the default formatter we have just configured will be used for formatting. And by the way, in order for this to work, the corresponding formatter called prettier should be installed. Now let's configure a couple of keyboard shortcuts. In the same way, I'm going to create a local file called keybindings.json where I'm gonna put all my keyboard shortcuts, but in order for these keyboard shortcuts to work, they should be added to the default VS Code's keybindings.json file, where we specify new keyboard shortcuts or override existing ones. Once again, I'm only adding these local JSON files to commit them to the GitHub repository, so these configurations should be added to the corresponding VS Code files called settings or keybindings.json. I'm going to apply formatting to files almost all the time, so I prefer to bind this command to a keyboard shortcut. In my case, it will be Alt-Command-K. The command we are about to bind this keyboard shortcut is called editor.action.formatDocument. Then I'm going to specify a pretty long condition, which will define where this keyboard shortcut should be activated. And you don't have to remember this condition, since all these keyboard shortcuts can be specified via graphical user interface of VS Code. And these conditions will be automatically generated and added to your configuration files. In order to specify keyboard shortcuts via graphical user interface, we can run the following command: open keyboard shortcuts, and we'll see such UI where we can search for the commands and then assign keyboard shortcuts to these commands. And then corresponding setting will be added to your default keybindings.json file. So now if I'm gonna go back to the view component, break the formatting of this file, and then press that keyboard shortcuts we have just defined, we're gonna see that file was formatted. Next, I would like to apply automatic sorting for all these import statements so that they will go in the alphabetical order. And VS Code provides us with a command to sort these imports. Let's find the command in the UI where we redefine keyboard shortcuts. Let's search for organize imports command. And right here we can assign the keyboard shortcut we wish to use for this command. I'm gonna use command +7. After that, corresponding configuration has been added to keybindings.json. From here I'm gonna copy over this keyboard shortcut setting and move it into the local keybindings.json file so that all these keyboard shortcuts will be committed to the GitHub repository. But you actually don't have to add all these settings to local.json files. So now let's try it out. I'm going to reorder these imports. Let's put these two import to view components in the middle and then press Command 7. And as you can see, all these imports were sorted. The order is alphabetical, but view components were automatically moved to the end. And also, if we would have some unused imports, for example, let's add an unused import in here and then press Command 7. As you can see, unused import was removed. Moving on, since our project uses static analyzer called ESLint, and just because we have installed an extension called ESLint in the previous lesson, that means that all ESLint violations will be shown directly in VS Code. So let's just reproduce some violation in this file. For example, let's use special parameter called arguments in the closure of the computed function. Right away, this violation was highlighted, and we can also see description of this error. But to make it easier to navigate between these violations, I prefer to define a couple of keyboard shortcuts to navigate to the next or previous violation. Just for the reference, I'm going to add the code to redefine these keyboard shortcuts to the local file keybindings.json, so it will be committed to GitHub repository. Firstly, I'm gonna specify command 8 to go to the previous error, and then let's duplicate this object once again and specify command to move to the next error. The keyboard shortcut will be command 9. So after that, if we'll open up view component once again and press either command 8 or command 9, we're gonna see such panel with the error description. And if we're gonna have more of those errors, by pressing command 9 or command 8, we can navigate between all these errors within the current file, and I find this workflow to be pretty convenient. So all these settings that we have defined in this lesson will be available in the GitHub repository, and the link to the repository will be in the video description. In this lesson, we're going to configure TypeScript compiler, so that anytime we're going to build our project, the TypeScript will run all checks and make sure that all types are properly used in our project. And if there will be any type mismatches, TypeScript compiler will prevent our project from being built. So we're going to start with adding some TypeScript code in our main JavaScript file called main.js. Let's declare a new constant name, which will be of type string, and assign wrong type, which is number. And then let's just print out the value of this constant in a console. By the way, if we hover over on this string type, we will see such pop-up, and TypeScript error is formatted, and this is due to that plugin we have installed earlier called TS errors, which formats TypeScript errors in more readable way. Now let's read the error message. It's saying that type annotations can only be used in TypeScript files, but we are currently in a JavaScript file. So to make it work, we have to rename this file in a way that it will use TS extension, and also in that place we are referring to this file when we're including this on HTML page. Right here we also have to change JS extension on TS. So now that we have type mismatch in our main.ts file, let's try to build our project by running npm run build in the terminal. As we can see, the project was built successfully, even though we have a type mismatch in our source code. Now let's also take a look how built project looks like in a browser. We can check it by running npm run preview, which will serve build project in the browser. So let's open up this address localhost 4173 in the browser. In here we also don't have any errors, and that variable's value was printed. So clearly, TypeScript type checking doesn't work yet. And now to make TypeScript to check types before we will build our project, we're gonna use a special tool from the family of tools called Vue.js language tools. And the tool that we need in here is called vite.tsc. And this tool will be used to run type checking in our source code. So first of all, we have to install this tool and then use this script to run type checking before we build our project. Let's open up package.json. And right before the command which builds our project, we specify another executable file vue.tsc to run type checking. But of course, in order for this to work, we have to install a couple of tools. Let's go back to the terminal and run npm install with a flag d, because we are installing dependencies that are only going to be used in development. In this case, we need the TypeScript compiler itself, because Vue.tsc tool relies on it. And let's also install Vue.tsc. And after installation process complete, if we take a look inside Node.js folder, here will be another folder called bin, and inside this folder we're gonna see executable file of Vue.tsc utility. Now we're gonna try to run this file in the terminal. For this we need to specify the path to this executable, which is node modulus.bin and the name Vue.tsc. After running this utility, we just see the documentation of how this tool should be used. That is because in order for TypeScript compiler to check types, we have to create configuration file in the root of our project called tsconfig.json. So let's do it right now. I'm going to create the new file in the root of the project. And here we're gonna be configuring TypeScript compiler, and all the options for TypeScript compiler are specified in the object under compiler options key. Let's create this object right here. And now we are ready to run TypeScript and build our project again. And by the way, we can just simply execute build script without having to specify the path to the Vue TypeScript compiler. And it is going to run TypeScript compiler before our project gets built. And once we do so, we will see the error saying JS-emit is not supported. That is because TypeScript is currently trying to compile TypeScript files into JavaScript files, but actually our project uses only JavaScript files. And by default, JavaScript files are not allowed in TypeScript projects. So let's just open up package.json once again and consider build script once more. So currently Vue.tsc tool, besides checking types in our source code, is trying to generate JavaScript files based on TypeScript source files. But we actually don't need to do this, because Vite itself will compile TypeScript files in the JavaScript files once we run vite build command. And what we need Vue.tsc tool to do is to actually check our types without having to compile TypeScript code into JavaScript code. And to avoid compilation, we can specify the option with the name noEmit in the TypeScript configuration file. The value of this option will be true, which means we're disabling TypeScript compilation. And now let's run the build once again. This time we're getting different error message, which says that JavaScript files are not allowed. So once again, let's go back to tsconfig.json and allow JavaScript files. For this, we need to use an option with the name allow.js and the value true, like so. And this time, after executing build again, we're getting an issue which is related to our source code, which indicates that we have type mismatch. So if I'm gonna go ahead and fix that type mismatch issue inside main.ts by assigning string to this constant, and by the way, the name constant is still highlighted, this error is related to ESLint, which we will fix later. But now that we have fixed type mismatch, let's run the build again. This time we get another error saying that type set is not supported. In the JavaScript version, we're trying to compile TypeScript code too, because the type set appeared in the ECMAScript 2015. So we have to specify the target of our compilation to the version which is later or equal to ES 2015. And we're doing it by adding another configuration option with the name target. And the version we're gonna use will be ECMAScript 2020. So once again, let's run the build. And we're getting the error saying that it wasn't able to resolve an import of Vue library. So the issue here is that TypeScript cannot resolve ECMAScript imports. And to fix this issue, let's specify configuration option with the name module resolution. We have to use the value bundler. This changes strategy of the module resolution. And this time, if we'll run the build again, we're going to see a new error. And this happens because TypeScript is also trying to check types within declaration files of some libraries. But we actually don't need to check declaration files of third-party libraries, so we can disable this behavior. We basically have to add an option with the name skip leap checks and the value true. And finally, after adding all these configuration options, we can run the build once again, and this time, as we can see, the project was successfully built. Let's run the build project in the browser by running npm run preview. And in here we also don't have any issues, and the variable value was printed in the console. So let's go back to the main.ts and reproduce type mismatch again by assigning number to this constant and build the project. This time, TypeScript compiler is not going to allow us to build the project because we clearly have type mismatch in our source code. So in this lesson, we have successfully configured TypeScript compiler. Let's temporarily rename this file to JS and also change extension from TS to JS in this HTML file and continue development in the next lesson. And the link to the source code of this project will be in the video description. Now that we have configured TypeScript compiler, it's time to configure another tool, linter called ESLint. In the first lesson of this series, we have already installed a VS Code extension called ESLint in order for all ESLint errors to show up in the editor. But currently in our project, ESLint doesn't recognize TypeScript syntax. Let's try to write some TypeScript code in one of the Vue components, for example in the root component app.vue. And by the way, to be able to use TypeScript syntax inside Vue components, we have to specify special attribute on this script element called lang with the value ts, like so. And right away we can see that type is no longer highlighted, but still variable name is highlighted. As we can see, this error is related to ESLint, because ESLint still doesn't recognize TypeScript syntax. So now we'll have to teach ESLint to understand TypeScript. And by the way, if we'll take a look inside package.json, here we can see that we already have pre-configured script that is going to run linter. That is this script called lint. So we can try to run this script from the terminal by executing npm run lint. Let's try it out. As we can see, linter has found a couple of errors, including that error inside the app.vue components where we have just modified the code and used type annotation. So in order to make ESLint understand TypeScript code, we'll have to add another set of rules inside ESLint configuration file to this extends array. But of course, firstly, this set of rules has to be installed, and we can do so by installing the following package. So we'll have to run npm install and specify this package name in the terminal in order to install this package. Let's go back to the terminal and run npm install with just copied package name. And since this dependency will only be used during development, let's not forget and specify flag d as we are executing npm install. This package provides us with another set of rules that we can include in this array, and the rule is called view ESLint config TypeScript. And now ESLint should understand TypeScript code. And indeed, if we take a look inside app.view component, we no longer see any errors. But if we're going to run ESLint from the terminal again by running npm runlint, we still can see a couple of errors related to configuration files of post.css as well as Tailwind CSS. But before fixing these issues, let's once again go back to package.json, and to this list of extensions, we also have to add another extension called .ts, since we need ESLint to also detect errors in TypeScript files. So let's try to reproduce TypeScript error in one of the JavaScript files. For example, let's add special argument in here called arguments, which is not recommended to be used, so ESLint should actually give us an error. And also let's rename this file so it uses TS extension instead of JS. Let's go back to the terminal once again and run the linter. As we can see, we have a couple of errors related to the code we have just modified inside functions.ts. So we have verified that now linter runs in the files with TS extension. Let's just revert all the changes we have made to functions.ts and also rename this extension back to JS and rerun the linter. And now we're gonna get to fixing the remaining issues. Firstly, let's start with post.css config.js. As we can see, this file uses common.js modules that are usually used in Node.js environment. And to fix this issue, let's rename an extension of this file on C.js, which means common.js. This way, we're gonna let linter know that this file uses Node.js module system. But that's actually not enough, and we also need to write additional code inside ESLint configuration file. So right here, I'm going to add another key overrides, which will be an array with one object. And inside this object, we have to specify the key files with the list of files, which we would like linter to treat as Node.js files. So right here, I'm going to specify an env object with one property node, which will be true. And this way, if we go back to post.css config.cjs file, we no longer see any errors. So that is fixed. Let's rerun linter once again. And now we have only one issue remaining. That is actually the same issue. So to fix it, we just need to add another entry to this files array, which is file name tailwind.config.js. And just like that, we have fixed all linter errors. So before finishing this lesson, let's just revert all the changes being made to the app.view component. And let's continue in the next lesson. The link to the repository with the source code of this project will be in the video description. Earlier in this course, we have installed a plugin called Prettier to automatically format source files. It works, but it will be even better if we could automatically format Tailwind CSS classes. And thankfully, there is a plugin for Prettier which is going to do exactly that. So here is an instruction how to install this plugin. First of all, we have to install corresponding npm package called Prettier plugin Tailwind CSS. Let's go back to the terminal and run the following command. But Prettier itself is already installed, so we don't have to install it the second time. And after this plugin is installed, we have to add the line which is going to include this plugin in the Prettier itself. So let's copy this line, open up Prettier rc.json, and paste it right here. After this, let's open up app.view component and change the order of these classes. And after I'm going to press keyboard shortcut to format this file, let's watch for the order of these classes. As we can see, the order was changed, so that means our plugin works fine. Now let's switch back to the terminal and run development server by running npm run dev. As we can see, we have this warning, which is pretty easy to fix. We just have to open up package.json and here add one property called type with the value module, like so. And once again, let's run development server and make sure that that warning is gone. As we can see, there is no warning anymore. And while we are in this file, let's rename the package name onTimeTracker. Also, let's open up index.html and change the title onTimeTracker. Let's do the same thing inside readme.md. Right here, there is also a constant called upName defined inside constants.js. Let's change this value onTimeTracker and rename this constant on local storage key, because this constant is only used to save or load upstate from local storage. This is all happening inside of storage.js module, so we have to change all references to previous upName constant on the new constant, local storage key. Let's do it in all the places, as well as while we are importing this constant right here. Next, let's go ahead and update the logo of the application. Now we are using an image for the logo, but we are going to use an icon instead. So the component responsible for rendering the logo called theLogo, right here in the template we can see that the img tag is used. Let's remove this tag, as well as an image that the tag was referring to. And instead we're going to use an icon. First of all, let's import an icon name, which will serve as a logo. It's called icon clock, that we are going to import from an icons module, like so. And also we have to import base component for the icon, called baseIcon. And now the way we can use this component is as follows. First of all, let's add this component right here. Also we have to pass one property called name, where we're gonna specify the name of the icon, which is stored inside icon clock constant. And we can also specify additional CSS classes. So for this icon, let's use h5, which will specify the height. But actually, baseIcon component gets exported as a default export, so there is no need to use these curly braces right here. And now if we'll take a look in the browser, we can see that inside of the logo component we have a new component called baseIcon, and in the top left corner of the application we can see the new icon. So now we have to style it properly. Let's apply a couple of classes to this A element. First of all, we're going to make the logo black, but the icon color itself will be white. And let's also add spacing from all sides and round corners a bit by using class rounded. Now it's looking better. Let's also make the size of this icon a little bit bigger by using class scale 125. But right now, if we take a closer look at this logo, we can see that the icon overflows on top of our padding area. We just have to change the origin from where transformation is applied. So instead of using center, we're going to use left size of an icon as an origin. So let's use origin left class. Now it's looking better and the icon doesn't overflow padding area anymore. Let's switch gears and talk a little bit about TypeScript support in Visual Studio Code. Earlier we have installed extension called Volar, which provides support for TypeScript in Vue applications. But the thing is that Visual Studio Code already has a built-in extension which provides support for TypeScript. And in order for those two extensions to not interfere with each other, it is recommended to disable built-in extension, as it's shown right here. So we have to open up extensions panel in VS Code, search for built-in extension called TypeScript, and disable it. We're gonna disable it for the current project, instead of disabling it globally. After this, we have to restart Visual Studio Code. And at the end, let's make sure that our application still works. Let's run development server, switch over to the browser and make sure that there are no errors. As we can see, it's looking good. Let's continue development in the next lesson, and the link to the repository with this project will be in the video description. From this lesson, we're going to start converting JavaScript files into TypeScript files, and after we are done with that, we're going to integrate TypeScript in view components. So let's start with the first JavaScript file, activities.js. First of all, let's change extension of this file on TS. We're also going to use strict mode of TypeScript in order for TypeScript to be as strict as possible when notifying us about possible errors. So let's open up configuration file tsconfig.json, and to enable strict mode, let's add property strict with the value true, like so. And if we'll go back to activities.ts, right away we can see several places that are highlighted. Those are the places where TypeScript couldn't automatically determine the type. So now we're gonna fix all of those issues one by one. Let's go from the top. And the first variable we're going to type is this activities reactive variable. This variable is supposed to store array of activities objects. Let's open up our application and see what shape each activity object has. As we can see, activity object consists of three properties: ID, name, and seconds to complete. And in order to describe an object of such shape, we're going to use an interface. So let's declare a new interface in here with the name activity and describe the shape of activity object. As we have just seen, this object should have three properties: ID, name, and seconds to complete. And now let's specify type for each of these properties. So property ID should be string, property name will be string as well, and property seconds to complete will contain numeric value. Therefore, it will have a number type. And if we'll take a look at activities reactive array, we can see that TypeScript has determined the type automatically, but this is not the correct type. So we're going to explicitly specify the type that this variable should have, and we can do so by using generic type argument when calling function ref, like so. And this way we're telling TypeScript that activities variable should store array of activity objects. Let's move on and switch over to direct activities computed property. As we can see, TypeScript was able to automatically determine the correct type for this computed property, and the type was determined based on the return value of the closure that we have passed to computed function. But what if we'll make mistake and accidentally return wrong type from this closure? This way, direct activities computed property will get wrong type. So I prefer to explicitly type this property by using generic type annotation, like this. And after this, if we're going to return wrong type from this closure, TypeScript will notify us right away. Let's also explicitly annotate return value of the closure that we pass to filter method. So this closure should return value of the boolean type. And just to make our intention explicit in here, we're going to manually compare seconds to complete to 0, instead of letting JavaScript convert type for us. And now TypeScript is happy, we are returning boolean value in here. Let's move on. The next computed property is ActivitySelect options. Let's take a look at our application and see where this property is used. And it's used on TimelineItems page in order for render this select list of activities. And if we'll inspect this component in View DevTools, we will see that every object from ActivitySelect options array should have two properties, value and label. Therefore, we have to make sure that generateActivitySelect options function returns proper value. As we can see, it returns array of objects with two properties, value and label. So let's go up and declare a new interface to describe this data type. We'll call this interface ActivitySelect option. So it will have two properties, value and a label, and both of these properties will be string. So now we can use this newly declared type to use as type annotation for ActivitySelect options computed property like this. And this way TypeScript knows a lot more about type of this property. So let's keep going. Next up is function initialize activities. it takes one parameter, which is some kind of a state. We don't know yet what this state is, since it is declared in a different JavaScript module. For now, let's use type annotation any, which is basically going to disable type checks. It's actually not recommended to use any type annotation, but we are only doing this temporarily since we are converting every JavaScript module in isolation. Later we're gonna get back to this place and update this type annotation with proper type. And also I prefer to explicitly assign type annotations for return values of functions, because if, for example, we're going to make a mistake and return wrong data type, TypeScript is not going to tell us that we have returned wrong data type. So let's use explicit type annotations for return values. And since this function is not supposed to return anything, for such cases we're using type called void. So let's get back the previous code and move on to the next function. So for this function we're gonna use type annotation activity for the first parameter. This is that type that we have declared earlier in this lesson. And this function also does not return anything, so I'm going to use void data type as a return value in here. Next up is update activity function. The first parameter will be of type activity. And as for the second parameter, we're temporarily going to use any type. And in the future lessons, we're gonna come back to this place. This function returns activity object, so let's explicitly state it and use activity type. The next function is delete activity. As the first parameter, it also accepts activity object, and as a return value, we use void, since it does not return anything. For the next function, the first parameter will be an activity object. We are just destructuring this object and extracting only one property, but we still can use type annotation activity. And the second parameter should be a number. And as we usually do, let's specify explicit type annotation for the return value. This function is supposed to return numeric value. Next one is calculate completion percentage. As the first parameter, we're passing number, total tracked seconds, and as the return value, this function also returns number. Moving on to total activity seconds to complete computed property. For this property, TypeScript was able to automatically determine the correct type, but we are still going to explicitly annotate the return value of the closure that we pass to method map right here, because if we're gonna make a mistake and return wrong value by accident, TypeScript is not going to tell us about it unless we use type annotation for return value. And as for the closure of the reduce method, as we can see, TypeScript was able to properly infer types for these both parameters, total and seconds. And finally, there is one more function in this file, which is generate activity select options. So the first parameter should be an array of activities. Let's use a proper type annotation. And as for the return value, this function is supposed to return array of other objects, specifically activity select option objects. So once again, if we're going to return a wrong value from this closure, we are not gonna get any error. But if we're going to use explicit type annotation for return value, we're gonna see an error. So let's keep this type annotation right here. And in addition to that, if we'll try to use unknown property, we're gonna see that it does not accept this property because earlier declared interface called activity select option does not contain that property. So let's get rid of that extra property, apply formatting to this file, and finish this lesson. The link to the source code of this project will be in the video description. In this lesson, we're going to convert another JavaScript file to TypeScript, and that is constants.js. Right here, we can see that we have three constants that have values of the valid pages. So why don't we create a separate type that would determine which page names are actually valid. Let's use type alias and call this type PageName. And to define this type, we're going to basically use union type and combine types of the following constants: page timeline, page activities, and page progress. We're also using operator typeOf to extract type of each of these constants. And eventually we're gonna get union type, which will allow only 3 values: timeline, activities, and progress. Later we're gonna use this type, but for now let's scroll down and consider the following array: NavItems. As we can see, it stores objects with 2 properties. So let's declare a separate interface to describe the shape of these objects. Let's call this interface NavItem. As we can see, it is supposed to store 2 properties, page and icon. And by the way, property page should store only valid page names. And since we have already declared the type which describes valid page names, it's called PageName. So let's use this type as the type for the page property. And as for another property icon, we're temporarily going to use type any right here, because everything related to icons is contained in another JavaScript module, which we're going to work on in the future lessons. Once again, using any type should be avoided, so we're definitely going to come back to this place in the future lessons. And now that we have a type for NavItem objects, let's use type annotation to describe the type for NavItem's constant. So this constant is supposed to store array of NavItem objects. And of course, in order for all those type annotations to work, we have to rename the file and use proper extension ts. And now if we scroll up and hover over on this page name type, we can see that this type allows only for 3 values, and those values are valid page names in our application. Next, if we're gonna scroll down further, right here we're gonna see several button types declared as a separate constants, and then all these types are gathered in ButtonTypes array. So just like we did for valid page names, we're going to declare a new type. Let's call this type ButtonType. And here I'm basically going to use union type to combine all valid button types into a single type, just like we have done for the page name type. So we're extracting the type of each constant and using union operator to combine all valid button types. And now after hovering over on this new type, we can see it only allows for the following button types. So that means if we're going to annotate this array which is supposed to store only valid button types with newly created type, and also we should use square brackets since this is an array of valid button types. This is going to prevent us from adding wrong data types to this array, because the moment we'll add wrong type, we're gonna see TypeScript error, because this string clearly is not valid button type. And at the bottom of this file there is this generate_select_options function call, and just because this function is defined in another JavaScript module, let's not try to properly type return value of this function just yet. For now we're going to use any type for this constant, and later when we're gonna properly type all JavaScript files, including the module where this function is defined, we're gonna come back to this place and use proper type instead of type any. Let's apply formatting to this file and finish this lesson. Link to the source code of this project will be in the video description. So let's continue converting our JavaScript files to TypeScript files, and in this lesson we're going to work on functions.js. Let's change the extension of this file on TS and start fixing all these errors. So the first parameter of this function, format seconds with sign, implicitly has an any type, So we have to manually specify proper type. It should be a number. And this function should return a string. The next function has pretty much the same signature. So as the first parameter, we're going to accept number. And as a return value, we'll use string type, like so. And by the way, let's not forget that in one of the earlier lessons we have registered keyboard shortcut that allows us to quickly navigate between all the errors in the file. Next, regarding the function normalizeSelectValue, since this function can take values of many different types, we're not gonna worry about giving this function a proper type for the parameter as well as for the return value. Let's put any for now, and in one of the next lesson we're gonna come back to this function, because we need to firstly see how this function is being used in order to give these a proper types. Moving on, and the next function is getProgressColorClass. As we can see, it accepts percentage, so the type of this parameter will be a number. And as for the return value of this function, as we can see, this function can return one of the 4 possible strings, and all those strings correspond to Tailwind CSS classes. So I suggest to declare custom type, which is going to describe all those possible values. And for this type, we're going to use enumeration, and let's give it a name, ProgressColorClass. Here we're basically going to list all possible values that variables of this type can take. In our case, it will be CSS classes that correspond to colors red, yellow, blue, and green. And now all we have to do is basically assign proper strings to these keys. For the yellow key, we're gonna use bgyellow 500, for the blue key, bgblue 500, and for the green key, bggreen 500, like so. And instead of returning strings, we're gonna do it in a little bit different way by using our enumeration. In this case, we are referencing key red. In here, we should reference key green. In the second case, it will be yellow. And finally, in the third case, it will be blue, like this. And now we can explicitly state that the return value of this function will be enumeration called ProgressColorClass. And if we're going to return wrong type, TypeScript is going to let us about it, that this function can only return one of 4 possible values that correspond to Tailwind CSS classes. So let's move on to the next function. The function ID is pretty simple, we just need to explicitly assign return type. It will be a string. The next function is generatePeriodSelectOptions. If we take a closer look at the implementation of this function, here we can see that this function returns an array of objects with 2 keys, value and the label. And to describe the shape of these objects, I prefer to create a separate interface. Let's call this interface PeriodSelectOption, where we will mention all the keys needed to describe objects of this type. Just like we have seen before, here we should include 2 keys with names value and the label. The value will have a numeric type and the label will have a string type. And now let's scroll down to generatePeriodSelectOptions function and manually specify type of the return value, which will be PeriodSelectOption object. But in this case, it will not just be an object, but an array of such objects. So it's important to also mention square brackets like this. And since we're manually specifying return values for functions, we also include return type for this function. So here we are returning one object of type PeriodSelectOption. And as for the keys of these objects, as we can see, TypeScript was able to automatically infer proper types for these keys. Let's consider the last function in this file. It will be pretty simple to assign correct types for the parameter as well as for the return value. So the parameter should be a number and the return value will be a string. In the body of this function, we're also referencing native method called butStart. But if we'll take a look at the signature of this method, we can see in here that the second parameter of this function should be of type either string or undefined. But as we can see in here, we're passing number, so let's manually convert these numbers to strings, like this. And just to make it clear, let me remind you where objects of period select option type are used. They are used as elements of the select element on activities page. So all these options are actually described by the objects of that type with keys value and label. The link to the source code of this project will be, as always, in the video description. Let's continue and open up the next JavaScript file, which is icons.js. Right away, let's change extension of this file on TS. And if we'll take a look at this module, we can see that this module is pretty simple. Here we just import several view components, then defining several constants, and eventually defining an object with keys that correspond to those constants and values that correspond to imported components. So since this module is pretty simple, let's come back to this in one of the next lessons when we're gonna start working on icons. And for now, let's move on and switch over to the next file, main.js. Let's change extension of this file on TS, and just because we are importing this file in index.html, here we also have to change this extension on TS. One more time, let's open up main.ts, and here we can just assign explicit type to the return value of disclosure. As we can see, disclosure does not return anything, so let's annotate this return type as void, like so. The next file is router.js. As always, the first thing we do is change the extension on TS. And let's consider the first constant, routes. This constant stores page components in such a format that every key corresponds to a valid page name and every value corresponds to page component. For now, let's just skip this constant and move on to the next one. And later in this lesson, we're gonna come back to the first constant. Let's consider current page constant. So this constant should store only valid page names. And as you may remember, in one of the previous lessons, we have already defined the type which describes valid page names, that is this type, PageName. And since we're gonna need this type in several files, let's just extract this type into a separate module. Let's call this module types.ts, cut that type from this file, and move it to our newly created file types.ts and export it from here. As we can see, this type depends on several constants, so let's just copy import of all these constants from router.ts and move this import to types.ts. And now we easily can reuse this type in several modules. First of all, let's go to constants.ts and import this type right here. But since this is only the type, we can explicitly mention it. When we are importing this, we just need to use type keyword like so. And this way we're making it clear to readers of our code that the page name is actually the type. So now we're going to reuse this type as the type for current page constant inside router.ts. And of course, this should be imported from our types module. And just like in the previous file, let's mention keyword type while importing this module in here. But here we are facing a problem because currently TypeScript was able to infer that the type of the return value of normalized page hash function is a string, but our current page constant should store value of the type page name. So we need to explicitly say that normalized page hash function is going to return the value of the type page name. So let's use type annotation right here. And if we'll take a look inside of this conditional, in here TypeScript thinks that the page is of string type. But in fact, if we have gotten inside of this if, we know for sure that the page constant stores valid page name because isPageValid function checked this already inside if conditional. So we can explicitly cast the type of the page constant to page name like so. And now as we can see, TypeScript is happy. And of course, if we're gonna try to return invalid type from this function, right away we're gonna see an error. So this function is safe now. By now this file has only one error, which is related to the parameter page of the navigate function, here we just need to explicitly annotate type of this parameter, which is page name. And just like we're always doing, let's also mention that this function does not return anything, hence we are using void type in here. And now we are coming back to the first constant in this file, which is rows. As was mentioned before, this constant stores mapping between valid page names and corresponding page components. But if we're going to use another key here, which is not valid page name, TypeScript doesn't tell us that we have made a mistake. So we need to come up with a proper type to this constant, so that every time we're gonna use invalid values in this object, TypeScript will notify us about it. And thankfully, there is already a default type in TypeScript that we can use in here, and this type is called record. This is a generic type, which means it accepts type arguments, and as the first type argument, we have to specify the type of the keys of this object. And because we need to ensure that the keys of this object can only be valid page names, we're going to use our type page name right here. And as the second argument, we have to specify type of the values of those keys. For now, let's just put any. And right away we can see that TypeScript highlights invalid property right here, because this property is not valid page name. And also if this object will miss at least one page name, for example page progress, TypeScript is going to notify us that this object should contain all available page names. Because our custom type page name that we have specified as the first argument to the type record is actually a union of 3 strings. So all of these pages have to be included in this object, and then TypeScript will be happy. But still we can improve the type of this constant even further, because currently, if we'll try to use some invalid value for any of these keys, we're not gonna get any error, but we have to ensure that the values can only be valid view components. And for that we can import special type from the view library, which is called component, which describes all view components. And this type then we can use as the second argument to this record type like this. And now if we're going to use any value that is not view component for any of these keys, right away we're gonna see an error. So now the type is pretty good and this constant rows is safe. Let's go back to the browser and make sure that after all our changes we haven't broken our application. Let's continue development in the next lesson, and the link to the source code of this project will be as always in the video description. The next file we're going to integrate TypeScript into will be storage.js. So in here for the first function, let's annotate type of the return value as void, because this function does not return anything. And of course, let's not forget and change extension of this file on TS. And by the way, we don't have to explicitly specify type for the first parameter should load, because this type contains default value, based on which TypeScript is able to automatically infer the proper type. Let's continue and specify the type of the return value for the next function load state. Here, the type will also be void. But for the next function load from local storage, we have to specify custom type, which we're going to create. The type will be called state, because this function is actually used to load the state from local storage and parse it. And the state object has certain shape, which we can see if we scroll this file further. Right here, we see that the state object consists of 3 fields: timeline items, activities, and last, activate. So now we're going to create another interface to describe this type. Let's open up types.ts, where we described all custom types, and export new interface called state. Right here we're gonna paste all those properties, and now let's just define the types for each of these properties. So the first property, timeline items, is actually supposed to store array of timeline item objects, but just because we didn't define the type for timeline item object yet, we're gonna come back to this place in one of the next lessons, and for now let's just annotate the type as any. Once again, using any type is not recommended, but we are only doing it temporarily in here. The next property, activities, stores array of activity objects. And for activity object, we already have an interface called activity, so we can specify this interface in here, and also with square brackets, because activities property is supposed to store array of such objects. But the problem is that this interface is actually defined in another module called activities. So to be able to use it in another module, we're going to extract this interface from here and put it inside types.ts and export it from here. And of course, whenever we'll need to use the type activity, firstly we have to import this type. So let's add an import statement right here. And just because activity is just a type, let's explicitly say so while importing this type by mentioning keyword type in here, which will make things easier for readers of our code, because by just looking at this import statement, it's clear that activity is a type. And now we're gonna do the same with another type, ActivitySelect option. So let's cut this type from here and paste it to types.ts. Let's not forget and also use export statement right here, and then come back to activities.ts and add this type to the import statement. And finally, let's get back to our interface state, which is inside of types.ts, and let's also add type to the last activate property. This property stores date objects, so the type will be a date. This is a native type in JavaScript. Now let's go back to storage.ts and add an import statement for this type. As always, whenever we're gonna import the type, we're gonna use type keyword in the import statement like this. And there is actually one more function in this file that we can explicitly specify type of the return value for, which is this saveState function. This function does not return any value, so the type will be void. At the end, let's just apply formatting to this file and reorder imports. Link to the source code of this project will be in the video description. Moving on, and in this lesson we're going to work on the next module, time.js. Let's change the extension of this file on TS. As of now, we don't know yet the type of the return value of the today function, so let's skip this constant for now and come back to it at the end of this lesson. Let's type the next computed property seconds since midnight in percentage. As we usually do, we tend to explicitly specify type of the return value of all functions, so we'll specify that this closure returns value of the type number. And the same type we're going to use as the return type for the next closure in here. Also in here, TypeScript complains that we are trying to apply subtraction operation to the value of type date, which TypeScript doesn't like. So let's just suppress this error for now by casting this value to any, and later we're going to come back to this place and apply proper solution. The next computed property is called midnight, so in here we also manually specify type of the return value of this closure, which is number. The next two functions return date, so we'll use date type as the return value in here. And as for the next function, tomorrow, and by the way, we don't need to explicitly specify type for this constant tomorrow because TypeScript is able to infer this type automatically. Because earlier we have specified that the return value of the function today is object of type date. Moving on to the next function, end of hour. This function takes one parameter of type date, transforms it in some way, and returns new date object, so the return type will be also date. The next function is today checks that the past date corresponds to today's date, so the type of the first parameter will be date, and the type of the return value will be boolean. The next function, 2 seconds, is basically going to convert milliseconds that we passed as the first parameter to seconds. Therefore, the type for first parameter as well as for the return value will be number. And finally, the last function of this file, startCurrentDateTimer. As we can see, this function does not return anything, so the return type will be void. Also, we're trying to use the same return type for the function that we are passing inside setIntervalClosure, like so. But in this case, we also have to use long closure notation by using curly braces. And by doing this in this way, TypeScript is happy. And with that, we are finishing with this module. Let's just apply formatting to this file and reorder import statements. And by the way, there is no need to explicitly specify the type for the reactive variable now, because TypeScript is able to automatically infer the type based on the return value of the function today. Let's just take a quick look in the browser and see if there are any errors. Looks like everything is okay. Let's continue development in the next lesson. Let's continue integrating TypeScript into our JavaScript files, and in this lesson, we're going to work on the file TimelineItems. We're going to skip TimelineItem timer file for now because this module depends on the module TimelineItems. So I prefer to type TimelineItems file first. And this file encapsulates everything related to the entity TimelineItem. In our application, TimelineItem represents individual block on the timeline page. So let's start using types in this file. For the TimelineItem refs constant, we're not going to specify a proper type just yet, because in order to assign a proper type, we need to know how this constant is used in view component. So we're going to come back to this place later, and for now, I'm going to mark this place with an any type. The next constant TimelineItems stores array of TimelineItem objects. Let's take a look in the browser to see what shape TimelineItem objects have. If we take a look in View DevTools, we can see that every TimelineItem object contains 4 properties, and those are activity ID, activity seconds, hour, and is active. So let's create a new type to represent objects of such shape. We're going to use an interface and call it TimelineItem, and here we're going to list all those properties that we have just seen in View DevTools. And now for each of those properties, we're gonna define a type. So property hour stores individual hours. It will be a number type. Property activity ID stores identifiers of activities. And those identifiers are strings, but also this property might not contain any activity ID at all, so it can also be null. For activity seconds, we're going to assign number type, because this property stores amount of seconds. And eventually, for the isActive property, we're going to assign Boolean type. And after defining this type, we can assign it to TimelineItems constant. But of course, we also have to use square brackets, since this is an array of such objects. Moving on to the next computed property, activity TimelineItem. Here I'm going to specify an explicit type for the return value of the closure we're passing to computed function. As we can see, this closure can either return an object of type TimelineItem, or if such object will not be found in TimelineItems array, it will return undefined. So basically, this closure is looking for an active TimelineItem object inside TimelineItems array. And as for the return value of the closure we are passing inside find method, we use Boolean type. Next one is a watcher. There we also have to assign the type. The watcher function is a generic function, so we can specify with values of what type it works. In this case, it watches value of the type date. So let's manually specify the type in here. And this way we don't need to manually specify the types for each of these parameters that we are passing inside this closure, because based on the generic type argument, TypeScript is able to automatically infer proper types for these parameters. Additionally, we'll specify the type for the return value, which will be void. Moving on, and the next function is initialize TimelineItems. As we can see, it takes one parameter which is the state. And by the way, for the state, we have already defined a separate interface which describes objects of this type. And this interface looks like this. So let's use this interface in here and import it. And as we usually do when importing types, let's use keyword type right here. The return value of this function will be of type void because this function does not return anything. And as for this last active add constant, we don't need to manually type it because TypeScript was able to infer the type based on the assigned value, which is a date object. Moving on to the next function, update TimelineItem. As we can see, we have to explicitly specify types for these parameters. So the first parameter takes value of the type TimelineItem, and as for the second parameter, fields, we're not going to assign proper type just yet, but come back to this place later. So I'm going to mark this place with any type, because in this place we might use one of the standard TypeScript types, which we're gonna talk about in one of the next lessons. And eventually this function is going to return transformed TimelineItem object, therefore the return type will be TimelineItem. For the parameters of the next function, we're going to use TimelineItem, actually array of TimelineItem objects, and for the second parameter we're gonna use earlier defined type for activity objects. This type looks like this. So in here we're gonna use type activity and import it. Also, let's just combine these two import statements, because both of these types we're importing from the same module. Next, let's specify the type for the first parameter of the closure of for each function. So in here, the proper type will be TimelineItem. And let's add a type for the return value of this whole function, which is void, because this function does not actually return anything. And the same type we can specify as the return type for the closure of the for each method, like this. But here it's also important to use curly braces for this closure, otherwise return value of the function update TimelineItem will be taken as a return value of this whole closure. The next function, calculate tracked activity seconds, is basically going to have same types for parameters as the previous function. So the first parameter will have type TimelineItem array, and the second parameter will have type of activity. This function returns number type, and then we also specify type for the first parameter of the closure of the map method, which is TimelineItem object, and let's specify type for the return value of this closure, which is a number, because activity seconds property of TimelineItem object, as we can see, has numeric type. And for the closure that we are passing to reduce method, for parameters as well as for return value, we're going to use the same type in this case, which will be a number, like this. The next function takes two parameters, so the first parameter will be of type number, since it represents an hour, and the return value of this function will be void. And as for the following statement, as we can see, this statement references earlier declared array of refs called TimelineItem refs, but for now we don't know what elements these refs refer to. So I'm going to type this constant as any, and later, when we'll know for sure which elements those refs are actually referring to, we'll come back to this place and use a proper type for the constant EL. Moving on to the next function, reset timeline items. As we can see, this function does not return any value, so type of the return value will be void, and the same type we're gonna use in here as the return type for this closure. But also let's not forget and use curly braces in here. For the next function, we're going to use type date as the type for the first parameter last active at, and use type void for the return value. As we can see, TypeScript still highlights a couple of places in this function, that's because computed property ActivityItem may not contain any value. So in here, TypeScript is actually trying to protect us from potential errors. So for the time being, let's just disable these errors by casting the type of this computed property to any, like so. And also let's do the same in this place. We still have a couple of functions left in this file. The next one is calculate idle seconds. The type of the first parameter will be date, and the type for the return value will be number. In the body of this function, TypeScript doesn't like that we are trying to apply subtraction operation to dates. There is actually a proper way how we can avoid this error, but for now, let's cast these dates to any. This way we're going to disable those errors, but definitely going to come back and apply proper fix in one of the next lessons. But for now we're casting each of these dates to any. The next function as the first parameter takes array of TimelineItem objects, and as a second parameter takes an activity object. And eventually it returns new array of TimelineItem objects. Let's also specify a return type of this closure we're passing inside filter function. So here the type will be Boolean. And finally we have reached the last function in this file, generate timeline items. This function generates array of TimelineItem objects, so the return type will be array of timeline items. And as for the return value of this closure, we're going to use TimelineItem type, because on every iteration, this closure of the method map is going to generate new object of TimelineItem type. So at the end, let's just apply formatting to this file and reorder imports. And just to make sure that our application still functions properly and we are not getting any errors in the browser, let's just click around a bit in here and verify that there are no errors. Link to the source code of this project will be in the video description. The next JavaScript file in our application is called TimelineItem timer. Let's open up this file, change extension of this file on TS, and start typing variables. So for this ref TimelineItem timer, we're going to use union type as generic type for this function ref, like this, because value that is contained inside this variable can be either number or undefined. Because down here, as we can see, we are assigning reference of the timer created by setInterval function to the ref TimelineItem timer, and references to timers are represented as numbers. But of course now we cannot use boolean value as a default value for this ref, so if we're not going to specify any initial value of the ref, by default undefined will be used as a value. Moving on and consider the next function, start TimelineItem timer. Let's assign type for the first parameter, which will be TimelineItem object. And on the next line, we can see that TimelineItem object can also be undefined. And in this case, we are falling back to another property ActivityItem. So to indicate that some parameter of the function can be undefined, which means it is optional, we can specify so by using question mark right after parameter name, like so. As we can see, type TimelineItem is not found because we have to import it first, but it is currently defined inside TimelineItems module. So let's extract this type from here and put it inside types.ts, because this is the module where we are grouping all our custom types. Let's add an export keyword right here, and now we are going to import this type inside TimelineItems module as well as inside TimelineItem timer module. Let's just add type keyword in this import statement to indicate that TimelineItem is a type. And let's continue assigning types to functions and variables. As a return type of this function, we're going to use void, since this function doesn't return anything. And there are a couple of places that TypeScript highlights in this function. That is because TimelineItem variable can store value undefined. So we're going to come up with a proper solution in one of the next lessons, and for now, we're basically going to disable these errors by casting value stored inside TimelineItem variable to any, like so. I have already mentioned a few times that using any type is not recommended, and we are only doing it in here temporarily, just to disable some of these TypeScript errors, because in this function, TimelineItem variable can store value undefined, and that is why TypeScript is highlighting its usage. And we are basically disabling these errors by casting TimelineItem variable to any. Let's also specify the return type of this closure, which is void, and move on to the next function. So in here, we're also going to use void type as a return type, and to avoid TypeScript error related to active TimelineItem variable being undefined, we're going to cast this variable to any. And as for this error, earlier we have specified that TimelineItem timer ref can only be undefined or number. So instead of assigning boolean value, we're going to assign undefined. And the logic in this case is not going to change, because undefined value can be converted to boolean false. And finally, we have reached the last function in this file, resetTimelineItem timer. For this function, we're going to use TimelineItem type as the type for the first parameter, and as for the type of the return value, we're going to use void. Let's get back to the browser and click around a little bit to make sure that we haven't caused any errors by doing all those changes. And so far it's looking good. We don't see any errors in the browser. Let's continue development in the next one. The next JavaScript file in our project we're going to work on will be validators.js, and in this file we are grouping all validator functions that are mainly used to validate values of the props of view components. But now that we are using TypeScript, most of these functions will not be needed anymore, because we're mainly checking all types by using TypeScript. There is a high chance that we're going to remove this file in the future, but for now, I'm going to go through each of these functions and assign types for parameters as well as return values. It doesn't make sense to properly type these parameters for now, since we know that most likely we're going to remove this file. So I'm going to use type any for each parameter, and as for the type of the return value of these validator functions, all these functions return boolean value, either validation fails or succeeds. So I'm quickly going through every function and type parameters and return values. And once this is done, let's just take a look at a few examples where these validation functions are used. For example, if we take a look at isPageValid function, we'll see that this function is currently used inside router.ts. In here, we're basically checking page name that we have read from the hash of the URL of the page. Now let's consider another validator, is NavItem valid, and this validator is used to validate prop of the view component. So right here we are assigning this validation function to validate NavItem prop of NavItem component. But as I said before, since we're using TypeScript, all these validators are not necessary anymore, because TypeScript is going to check all types for us. At the end, we're going to apply formatting to validators.ts file and reorder import statements. And as we're going to work on view components, we're basically going to remove these validation functions one by one, because we can't really remove this whole file at this point, since all these validators are widely used in many view components. So let's continue development in the next lesson. Earlier in this course we were defining custom types, but at some point we have created a module called types.ts where we decided to group custom types. For now, not all custom types are grouped in this file. For example, type NavItem. As we can see, it is currently defined inside constants.ts. So in this lesson, I'm going to move all custom types and group them inside types module. Let's cut this interface declaration and paste it inside types.ts. From here, we're going to export this type and import it inside constants.ts. Let's also remove all unused imports and continue. There is also one more type called ButtonType in this file. We're also moving this type inside types.ts. And since this type relies on many constants, we have to import each of these constants in this file. We can grab an import statement for these constants from BaseButton component, move it in here, and since we already have one import which imports things from constants module, let's combine these two import statements into one. And now inside constant.ts, we're going to import ButtonType from the types module, like so. There are also a couple of custom types defined inside functions.ts. Let's cut this declaration of enumeration as well as interface and move it inside types.ts. And since we have to access these types from outside, we need to export them. Let's also move declaration of this enumeration at the end of this module and export it. Next, let's add all necessary import statements to import proper types. And by the way, there is one interesting use case, and it is related to how we use type progress color class. As we can see, this type is used as type of the return value of this function. So this is one way how we can use the type. But the thing is that enumeration can be used at the same time as the type as well as the value. Because in here, besides using progress color class enumeration as a return type, we're also using this type as a value by referencing individual enumeration entries in here as return values of this function, which means that we cannot simply use keyword type in this import statement because progress color class enumeration is used not only as a type but also as a value. So to fix this issue, we have to explicitly specify which things are imported as types and which things are imported as values by basically using keyword type in front of only types, but not of in front things that can also be used as values, like progress color class enumeration in our case. So to make sure that our application still functions properly, I'm going to take a quick look in the browser, click around a little bit and make sure that there are no errors. As we can see, everything is good. Let's continue development in the next lesson. Let's keep working on our project, and in this lesson we're going to use so-called generic type to combine two pretty similar types that are defined inside types.ts file. I'm talking about the following types: ActivitySelect option interface as well as period select option. If we take a closer look at both of these types, we will see that they're pretty much similar. The only difference is that inside the first interface for the property value we're using string type, and inside the second interface for that same property we're using numeric type. So in such cases we can leverage so-called generic type. And here's how it works. I'm going to declare another interface called select option, which is going to represent both types at the same time, activity select option as well as period select option. And here, instead of hard coding the type for the property value, we're going to use special placeholder. Usually it is called t. And so that concrete type that should be used in the place of this placeholder should be specified at the time when we're gonna use this interface. So basically in here we have to declare that this interface is the generic interface, which means it accepts one dynamic type argument, and we can do this by adding generic type argument like so by using angle brackets. And now let's find all the places where we are using ActivitySelect option interface and replace all those usages with our new interface select option. So let's take a look inside activities.ts, find all those places where ActivitySelect option interface is used, replace all these places, and use select option interface instead. But as we can see, those usages are currently highlighted because this interface is a generic one, which means we have to provide it with one type argument by using angle brackets like this and specifying the type this interface is going to use. In this case, since ActivitySelect option interface for the property value uses string, we're gonna have to pass string type, like so. And let's do the same for all other places in this file. And by the way, let's try to change type of the value for this value property and use number. And right away we're seeing that TypeScript highlights this place, because earlier we have specified that the return value of this function should be an interface select option with a dynamic type, which is string. And this dynamic type is used to type the property with the name value. So in this case, TypeScript complains because we are using number instead of a string for this property. But if we would do the opposite and specify number as a dynamic type argument and using number for the value property, in this case, everything will be okay. So let's revert these changes and use string instead. And now we're gonna do pretty much the same, but for another interface period select option. This interface is currently used inside functions.ts. So I'm going to search for all these places and replace these usages on our new dynamic interface select option. As we can see, for this interface, we're gonna have to provide generic type argument, which in this case will be number. So let's get back to functions.ts and use numeric type as a generic type argument for this interface everywhere. And let's test it out. So inside the function generate period select options, I'm going to use string value for the value property. And we see an error because in this case we have to change generic type argument on string. And also, since we have specified that this function returns array of select option objects with generic type argument number, we also have to change this generic type on string to make TypeScript happy. But we have just done this for testing. Let's just revert this as it was. And now we can go back to types.ts and safely remove this unused interface period select options. We were able to combine two pretty similar interfaces into one by using generic type argument. And in addition to that, we can also specify default value for this type argument like this. And now, when we are using select option interface with string generic type, we don't need to manually specify it because this type will be used by default. So again, whenever we are using select option and passing string value as a generic type, we don't need to do this anymore. So I'm going to remove all the mentions of this generic type in here. And in the end, there are a couple more places that I'd like to improve in this lesson, and that is this. Inside declaration of the state interface, we're using an anyType to type TimelineItem's property, but since we already have a type for TimelineItem objects, which is called TimelineItem, we can leverage this interface in here and also specify square brackets because TimelineItem's property is going to reference array of TimelineItem objects. And another thing is this one. Let's take a look at the ActivityID property inside TimelineItem interface. As we can see, we're using a union type for the ActivityID, and the type can be either string or null. But we can do this actually in a little bit different way and dynamically derive the type of the ID property of activity interface. So we're using an interface and referencing its ID field. And this way we're gonna get the same result. An activity ID is of type either string or null. But now we're doing it in a little bit more dynamic fashion. And whenever we're gonna change the type of the ID property of activity interface, at the same time it is going to affect this place and dynamically change the type of activity ID property of TimelineItem interface, since in here we are referencing activity interface. As always, link to the source code of this project will be in the video description. In this lesson, I suggest we go through all the files we have already typed and replace some of the usages of any type on more proper types. For example, inside activity.ts, we're using any type for this parameter state, but since we have already declared an interface which describes state objects, we can leverage this interface in here instead of using any type. Let's also not forget to import this type up above and move on to the next usage of any type. As for the second parameter of the update activity function, instead of using an any type, we're going to use default TypeScript type, which is called partial. This is a generic type which accepts one type argument. In our case, we're going to pass in here type of activity. And what this notation is going to do is it will ensure that we can only pass those objects as the second parameter of this function with properties that exist on objects of activity type. And if we're going to reference some property on this field's variable which doesn't exist on objects of any type, right away TypeScript is going to let us know about it, that this is undefined property. So we have to use only those properties that exist on objects of any type. Which means in our case, we can only reference these three properties: ID, name, and seconds to complete. Moving on to the next place where we are using any type. Inside of constants.ts, we're using any type for period select option constant. But now that we already have declared return type of generate period select options function right here, we don't need to explicitly specify the type of the constant which receives return value of this function, because TypeScript is able to infer the type based on the return value of the function. There are also a bunch of places where any type is currently used inside of TS files. Some of these places we're going to come back to later on, and for now let's consider the following place. Inside TimelineItems.ts file, specifically for update TimelineItem function, as the second parameter, we're using fields variable, just like we do for another similar function from activities.ts module, which we have already typed. And there we used partial type. So in this case, we're gonna use the same type, but as a generic type argument for the partial type, we have to use TimelineItem instead of an activity. And this way we will ensure that those objects that will be passed as the second parameter inside this update TimelineItem function should have only those properties that are present on objects of TimelineItem type. And this way we have made this function update TimelineItem a little bit safer. And lastly, let's go back to types.ts, and instead of using an any type for an icon property inside NavItem interface, since all our icon names will be strings, let's use more specific string type instead of any. As always, link to the source code of this project will be in the video description. By now we have already converted almost every JavaScript file into TypeScript file, but there are still a couple of files which are these two files, progress and total progress, that store composable functions. So in this lesson we're going to convert these remaining files into TypeScript as well. And actually converting these files will be no different than converting normal JavaScript files. So in here, first of all, we're going to assign explicit return types to each of these computed properties. Let's start with the first one. This computed property should return value of the type progress color class. So we're going to explicitly assign this type in here, just like we do for all functions. And then let's add an import statement for this file. And to highlight that this is a type, we're going to use keyword type in this statement like this. And of course, in order for types to work, we have to change extension of this file on TS. Then we're gonna assign type for the first parameter of this composable. This is an activity object which will already have a type for called activity. And as for other computed properties, these properties will return value of the type number. So let's specify this type for both properties. And by the way, based on the return value of this composable function, TypeScript was able to automatically derive type for the return value of this composable function. But we may make a mistake and return some wrong value from this function. So I prefer to copy this whole type and specify it explicitly as a return type in here. And what this gives us is if we're going to, for example, return some invalid type from this function, in this case TypeScript is going to let us know about it, that we have made a mistake. So I prefer to keep this explicit type in here. And by the way, computed ref type should be imported from the view package, like so. So now let's try to return some invalid value from this function and make sure that TypeScript is going to let us know that we have made a mistake. As we can see, it gives us an error. So we have guarantees that this function will return only valid values. So now that we have fully typed the first composable function, let's move on and do the same for another composable function, total progress. Here we're gonna do almost the same things. Firstly, we're going to assign return types for all these computed properties used inside this composable. The first computed property will return value of the type progress color class. And as always, this is a custom type, so it has to be imported. And other computed properties in this function will have a numeric type. So I'm gonna use number for both of these computed properties. Besides that, I also prefer to explicitly assign types for return values of closures that we pass to map as well as reduce functions. And both of these functions are also going to return numeric type. And by the way, TypeScript was able to automatically determine proper types for both parameters, total as well as seconds. At the end, just like we have done with previous composable function, we're going to manually assign type of the return value for this composable. Let's copy this type from here and use it as a return type. And also let's not forget and import computed ref type from the view package. That is going to give us additional guarantees and ensure that we are going to return only correct types from this composable function. So at this point we were able to convert all the JavaScript files in our application to TypeScript files. And in the next lesson we're going to work on view components and integrate TypeScript into files with an extension .view. Link to the source code of this project will be in the video description. In this lesson we're going to work on view components, since we have already converted all JavaScript files into TypeScript files. So now it's time to do the same with view components. And the first component we're going to start conversion with is ActivityItem.view. And just to remind you what this component is responsible for, let's take a look in the browser, open up Activities page, and add a new activity. And that activity item component is responsible for rendering individual list items in this activities list. And the first thing that we have to do before actually introducing TypeScript into view component is to assign special attribute to this script tag called length with the value of ts. And this gives us an ability to use TypeScript syntax inside view components. So for now we're going to skip the declaration of the prop activity and come back to it later. And firstly we're going to assign types to the parameter as well as the return value of the function delete and reset activity. So this function accepts objects of the activity type. Let's specify the proper type in here, which is an activity. And since this function does not return any value, the return type will be void. And now anytime we're gonna use the function delete and reset activity inside the script tag or inside our template, and if we're going to pass wrong value inside this function, which is not an activity object, right away TypeScript is going to give us an error. So that's that. Now we're gonna go back to define props macro. This macro is used to declare props of this component. But now, since we are using TypeScript, we also have an ability to specify types for every property that is accepted by component. And the syntax is actually different from that one we have used earlier. So first of all, I'm going to cut this whole object we're passing inside define props macro, because we're not gonna need it anymore. We have a different way of specifying types for props in TypeScript. So to properly type the value which is accepted by this component from outside, we're going to use generic type syntax and pass dynamic type by using angle brackets. And since this component accepts only one prop called activity, we're going to use the key activity, and then we assign the type for this property, which will be activity interface. So this notation is going to do pretty much the same effect as the previous notation. And by the way, as for this validator property, before we had to use custom validators to verify that we pass proper values inside view components, but now TypeScript is going to ensure we're passing correct types, since we explicitly declare types for props. So there is no need to use this validator key anymore, we can get rid of it. Along with that, let's also get rid of an import for isActivityValidValidator function in here, and use keyword type when we are importing activity type. We could also think that isActivityValid function is no longer needed, but actually if we search for this function in the whole project, we will see a couple of mentions of this function. That means it is still used in some components. So for the time being, let's keep this function around and come back to it once we're gonna type other components that use this function. So now that fact that we have explicitly specified the type for props activity, anywhere we're going to use this prop inside this component, ID is going to give us autocompletion, which wouldn't be the case if we wouldn't assign the type for the prop. So as we can see, using TypeScript gives us not only type safety, but also some cool advantages, such as proper ID autocompletes. So with that, there is only one error related to TypeScript inside this component, and this one is related to selected prop of another component, BaseSelect. We're going to type BaseSelect component in one of the next lessons, and for now I'll just disable this error by manually converting the result of this expression to any type like so. But we are definitely going to fix displays properly in the future lessons. So we have successfully converted our first view component to use TypeScript. Let's continue development in the next lesson. So now let's work on the view component which represents button in our application, and this component is called BaseButton. Let's open up this component in our editor. And this component, besides script tag with a keyword setup, which is used to configure component, we also have a normal script for general use. So we have to add attribute length with the value ts for both of these scripts. And the first thing we're going to type in this component is this type classes constant. This constant stores an object where keys are valid button types and values are strings that contain Tailwind CSS classes. And if we'll take a look where these button types are coming from, we actually see that these constants are defined inside of constants.ts, and all these constants are used to create custom type called ButtonType, which basically is a union of all these constants. So right here, for type classes constant, let's use default TypeScript type called record. This is a generic type which accepts two type arguments, where first argument will represent keys of the object and the second argument will represent values. So in our case, since all object keys should be valid button types, we're going to use our custom type ButtonType. And as the second argument, let's use any type for now. And right after we have assigned this type to type classes constant, we no longer can use arbitrary keys inside this object. Otherwise, we're going to get TypeScript error, because this key does not represent valid button type. And also, if we're going to not use any of existing button types, we also get an error, because the type that we have assigned to this constant requires us to use all available button type keys. But for now, if we're going to assign any value other than the string to one of these keys, we don't get any errors, but in fact we have to ensure that values can only be strings. So as the second argument to this generic type record, I'm going to use string instead of any. And this way, if we try to assign the value other than a string, right away TypeScript is going to inform us about it by highlighting invalid value. So as for another benefit that we're getting after assigning the type to type classes constant, is that whenever we're going to use type classes constant in this component, we're going to get a helpful autocomplete where all valid button types are listed. Now let's move on and type properties of this component. As usual, we're going to extract this argument, which was previously used to describe properties of this component. But now that we are using TypeScript, we're going to use generic type annotations, just like we have done in ActivityItem component. So I'm going to copy over this generic type argument from here and paste it into BaseButton component. But in here, instead of using activity property, we'll use property called type. And the type of this property should be a valid button type, which is represented by our custom type called ButtonType. But actually, in our previous declaration, we see that this property also has default value, so which means this property is not required to pass. And to specify that this property is not required, we're going to use question mark right after property name, like this. Besides that, previously we were also using custom function which was validating values of this property. This function was imported from Validators.ts. It is called isButtonTypeValid. So now we're not gonna need this function anymore. We can remove this function from here. Along with that, let's also remove unused import from this file, as well as an import of this function inside BaseButton component. And now we have to figure out how to actually specify default value for the property type, because previously we were assigning default value for default key, but now we're gonna do this a little bit differently by wrapping define props call into another function called withDefaults. And as a second argument to this function call, we're gonna have to supply an object where keys are property names and values are default values for those properties. And since we need to use default value for the property type, we're basically specifying that default value will be constant button type primary, just like before. So we don't need previous declaration of the property anymore, let's get rid of it. And if we'll try to reference props object, we're gonna get autocomplete with a single valid property name called type. And now let's see what is actually going to happen if we'll try to pass invalid button type to property type when we're using BaseButton component. For example, inside ActivityItem component, let's apply invalid value for the type property, and TypeScript is going to highlight this property because we're supplying invalid button type. So we have type safety now. And just to remind you what button type actually looks like, I'm going to switch over to types.ts file. Right here I'll find button type declaration. As we can see, this type consists of 5 button type constants. So it's basically a union of 5 valid button type values. And with that, we have successfully typed BaseButton component. Let's continue typing other components in the next lessons. The next component we're going to work on is called BaseSelect. This component represents select boxes in our application. Let's switch over to our editor, open up the file with this component, and start assigning types. First of all, as always, we're gonna have to assign attribute called length with the value ts on the script tag. This component contains quite a few properties, specifically 3 properties with names selected, placeholders, and options. So I'm going to cut this declaration from here, put it down here, and comment out for now. So we have a reference while we're gonna be converting this declaration into the new TypeScript declaration while we're gonna assign types for props. So in this case, let's list all these properties in this object, options, selected, as well as placeholder. And now let's assign types one by one to each of those properties. Let's start with the property options. If we take a look at the previous declaration, we can see that for this property we were using validator function called validateSelectOptions that is defined inside of validators.ts file. So in here, as we can see, we reference another function which is called ESLectOptionValid. And if we'll take a look at the definition of this function, we can see in here what validation rules are applied to validate select option. And now we basically have to replicate the same validation rules by using TypeScript notation. As we can see, select option is represented by an object with two properties called value and the label. Property value should be numeric or non-empty string, and at the same time property label should be non-empty string. Let's switch over back to BaseSelect component. First of all, I'm going to describe the shape of select option element. It should be an object with property value that should be either number or a string, and it should also contain property label, which will be a string. Since options property should be an array of such option objects, we're going to use square brackets right here. With the other properties, situation is much easier. So for the selected property, I'm going to use a union of three types: number, string, and null. And for the property placeholder, we're going to use a string type. Just like we were doing before, for the selected property we were using two types, and for the placeholder property we were using only one type, but using different notation. And now we can easily remove all this commented code, as well as all unused imports in this component. And after this, we can actually remove some of the validation functions that are no longer used. So let's switch over to validators.ts. First of all, let's remove validateSelectOptions functions since it is no longer used. And as for this function ESLectValueValid, this function is currently used to validate event payload of the BaseSelect component. We're going to come back to typing event payload a little bit later in this lesson. But for now we can just remove this function because we're not gonna need it anymore as well. And there are also a couple more unused functions. Those are isNumber or null. Let's get rid of this function, as well as isSelectOptionValid. Let's remove this one as well. And now we're going back to BaseSelect component and start assigning type for the event. This component fires only one event with the name select. So I'm going to extract this event declaration from here and use it as a reference while we're gonna be using TypeScript notation to properly type event as well as its payload. And the way we're assigning types to events is pretty much the same as for properties, but the notation will be a little bit different. So right here, inside this object notation, we're going to use brackets, and inside these brackets, we have to use key value pairs. There is a special key called E, which will represent the name of the event, which will be fired by this component. As we can see, the event name in our case is select. Then we also have to specify type of the payload of this event, which is going to be sent over once we're gonna fire this event to parent component. And in this case, type of the payload will be a union of three types: number, string, and null. And eventually, the function emit, which will be used to fire these events, will not return anything, so we're going to use type void. And now if we're going to try to fire any other event, which is not equal to select, we're going to see that TypeScript complains about it because this component is only able to fire only one event with a name called select. just like we have specified in here. And the payload of this event should be either number, string, or null. And if we'll try to assign another payload type, TypeScript is also going to complain about this. In addition to that, if we'll try to use function emit, we're gonna get helpful autocomplete with the list of all available events to us. So this way, we'll not fire invalid event by mistake. But actually, in more recent versions of Vue, we got another more concise syntax to describe events. So now let's comment out this line and use new syntax to describe an event. And if we'll use this new syntax, we have to use key value pairs. So the key should correspond to the event name we're gonna be firing. In our case, it is select. And as a value, we're going to specify another TypeScript type called tuple. Here we're also going to use a key, which will be the name of our payload. And as a value for this key, we have to specify payload type. So in our case, it will be a union of three these types. So after describing the event by using the new syntax, let's also ensure that by specifying invalid event name, we're gonna get an error, as well as if we're going to specify invalid type for the payload of the event, we're also going to get red squiggly line. So everything's working good here. From now on, we're going to use the new syntax of defining events. So let's assign explicit type to the return value of the closure that we are passing inside computed function. In this case, the type will be Boolean. Then let's also specify the correct type for the parameter of the function called select. In here, it will be either string or null. And because this function does not return any value, we're going to use void type as the return type. But if we'll scroll down to the template, we can actually see that TypeScript complains about usage of this target property, because TypeScript doesn't know that this target property will store a reference to the select HTML element. Because to TypeScript, this target property can actually reference any HTML element, and even that HTML element that might not contain property value, and that is why this usage is highlighted. And to actually give TypeScript a hint and tell that target element will actually reference HTML select element, we're going to use typecasting and cast this expression to proper type. It will be HTML select element, like this. And now TypeScript knows that the target property will refer to select element which has property called value. And now TypeScript stops complaining. So eventually we're going to remove all unused imports in this component. And at this point, we were able to properly assign types to props of these components, as well as all events that this component can fire. Everything seems to be okay in this file, but if we'll actually open up ActivityItem component, we will see that TypeScript highlights one place in this file, which is related to seconds to complete property. And this is happening because seconds to complete property can only accept values of either type number or undefined. But the payload which is coming from the BaseSelect component along with event called select, this payload is stored inside special variable called $event, and this payload is of type string, number, or null. So here we have type mismatch. That is why TypeScript doesn't like this assignment. For the time being, I'm going to avoid this error by actually casting this variable to any type, and in the future lessons we're going to find the proper fix to this. And by the way, applying casting to any type of this expression is no longer needed, because in this lesson we have already typed property called selected, which is either string, number, or null. So TypeScript knows for sure what this property type should be, so we don't need to cast anything here anymore. If we'll take a look at the definition of props inside BaseSelect component right here, we can actually see that we have explicitly assigned type for the selected prop. And the type of that expression that we were assigning to this selected prop can either be number or null, which is compatible with selected property declaration. So now we have successfully finished conversion of another view component. Link to the source code of this project will be in the video description. In the previous lesson, we had to avoid one TypeScript error related to seconds to complete property inside ActivityItem component. In here, we are trying to assign event payload stored inside $event variable to seconds to complete property, which is actually of number type, but the event payload can be either number, string, or null. So in this lesson, we're going to fix this type inconsistency. Let's get rid of this cast into type any. And now let's take a look at the declaration of the event select inside BaseSelect component. As we can see in here, we have earlier specified that the payload of this event can be a union of 3 types. But this payload type will be actually dependent on another property we're passing inside of this component, specifically options property. So we can resolve this type inconsistency by using a generic component feature. So to convert this component into a generic component, we can use special attribute called generic on this script tag like this. And just like we usually create generic functions or generic classes by using TypeScript generics, we can also use generic components. So in here, we're going to use a similar syntax to define generic type argument, which is usually called T. And just to be more specific, what types this generic type can receive, we're going to extend this type by using the following syntax. And this is going to ensure that parameter T can be either of number type or string type. So now, anytime we're using a union of these types, we're going to go through this component and replace all such unions by using our newly created generic type T right here, also for the property selected, and also for the payload of the event select, like this. And now, based on the usage of BaseSelect component, and based on the value we're going to pass to property called options, TypeScript is actually going to automatically infer proper type for generic type argument based on the type of the key value. And just to better understand how this is going to work, let's see where this period select option value comes from and what shape it has. So in order to generate value for period select options constant, we're calling the function generate period select option. So we have to take a look at the definition of this function inside functions.ts. And right here we can see that the return value of this function is of another generic type called select option. Let's take a look at the definition of this type. As we can see, it consists of 2 properties, value as well as the label. And one of these properties actually has a generic type. And when we are using BaseSelect component right here, we can see that generic type argument was inferred, and instead of the generic type argument, number type was used. So then this type will be propagated down to BaseSelect component and used instead of this generic T type. So basically, when we're using this component, generic type T will be replaced on the number type. And eventually what this is going to give us is that this $event payload will now be more concrete type, which will be either number or null. And as we can see, $event variable has a type of number or null, which is completely compatible with the type of seconds to complete property. And there is no more TypeScript error in this case. But there is one little thing we can improve by going to BaseSelect component. So let's take a look at the shape of this select option object. This object is very similar to the definition of select option interface. So why don't we just use this interface instead of repeatedly describing this shape right here? But just because this interface also expects one generic type argument, let's just pass over our generic type T to this type argument like this. And while we're importing this type select option, let's use type keyword to highlight that this is a type. So in this lesson, we have used the pretty cool feature of TypeScript in combination with Vue, which is generic components, which lets us use more specific types inside our components. Alright, the next component we gotta work on is called NavItem component. This component is responsible for rendering navigation items down here. So as always, let's open up this component in our editor and assign attribute link to the script tag to be able to use TypeScript inside this component. And let's start from the property declarations. I'm going to extract previous declaration, comment it out for the reference, and we're going to use TypeScript annotation to properly type props. In this case, component accepts only one property called NavItem, and thankfully we already have a type which describes objects of this shape. This type is called NavItem, so let's reuse this type right here. I'm going to use interface NavItem and import this interface in the file. Previously, we were also using validation function isNavItemValid to ensure that only valid objects can be passed as props inside this component. But now that we are relying on TypeScript types to provide type safety, we no longer need to use this validation function, so we can safely remove this. Along with that, let's also remove all commented code inside NavItem component, including this import statement, and assign types to the rest of elements inside this component. So the type of the return value of the closure we're passing to computed property in here will be array of strings, and the return type of the function handleClick will be void. As we can see, this function does not return any value. So let's see what benefits we get by explicitly assigning types to properties in this component. If I'm going to use invalid property which does not exist on the interface NavItem, TypeScript complains about it by highlighting this usage. And also, if we'll try to reference some property from NavItem object, we're gonna get this helpful autocomplete with the list of valid properties. And TypeScript was able to pick those valid properties based on our interface NavItem. So after doing all these changes, let's just ensure that our application works properly. I'm going to switch over to the browser and click around a little bit by simply trying to navigate between different pages. As we can see, everything is working good. Let's continue development in the next lesson. Alright, the next component we're going to work on will be progress item component, and this component is responsible for rendering list items on the progress page right here. So the first thing we're going to do in here is actually type props. This component accepts only one prop with a name activity, and the type of this prop will be activity itself, which we're going to import from types.ts. This is an interface we have defined earlier. As always, to be consistent, let's use word type while importing types. So we no longer have to use validation function to validate activity prop, so let's remove this import as well as this commented code. There is actually nothing else in this component that we could type, so let's move on and switch over to the next component, which will be remaining activity seconds. This component is responsible for rendering amount of seconds next to every activity list item. And as we can see in View Developer Tools, this component accepts one property with the name activity, just like the previous component. So what we could do in here is actually copy over the dynamic argument we have just used from the progress item component and paste it into this define props declaration inside remaining activity seconds component. Then we're going to import this interface inside this file and remove unused import. Also in this component we have a couple of things that we can assign explicit types for. For example, this computed property, the return value of this closure will be an array of strings. And as for remaining seconds computed property, the return type for this closure will be number. Moving on and switch over to the next component, the activity empty state. As we can see, this component doesn't have any scripts, so we can simply skip it and move on to the next one, the activity form. And this component is responsible for showing the activity creation form on the activities page. In this component, we don't have to explicitly assign the type for this name reactive variable, since TypeScript is able to automatically derive the proper type based on the initial value of this reactive variable. And as for the next function, since this function is asynchronous, it is going to return a promise. So we can use default type called promise as the return type for this function. And just because this promise is not going to hold any data, we use dynamic type argument void as the generic type. As always, before typing any view component, we have to apply attribute length with the value ts on the script tag. So we're done with this component. Move on to the next one, the header. This component renders the bar at the top of the page. As you can see, it does not contain any logic besides importing a couple of other components, so we could just assign attribute length with the value ts and move on to the next component. And as for the next component, it is contained inside the header component and responsible for showing the label at the top right corner of the application. There is not much logic in this component as well, so we can simply assign attribute length with the value ts and move on. The next component is called the logo, and it renders nothing else but simple logo of the application. So this component does not contain any logic as well, besides one function. So we can just assign return type of this function, which will be void. And lastly, we're gonna open up the next component, the now, which is responsible for showing navigation at the bottom of the page. In this component, we just add attribute length, and that will be it, because this is also a pretty simple component, just like other ones. And just to show you what the now component looks like, it is down here. This component contains other NavItem components responsible for rendering individual NavItems. And with that, we are finishing this lesson. Link to the repository of this project will be, as always, in the video description. In this lesson, we'll continue introducing TypeScript into view components. The next component is the progress empty state. So in here, as we can see, component does not have any logic, so there is nothing to use TypeScript for. We can move on to the next component, the TimelineIndicator component. And this component is used on the timeline page, and it is responsible for showing red horizontal line as an indicator of the current time of the day. So as always, in this component, the first thing we're gonna do is add attribute length with the value ts and continue typing in elements of this component. As for this template ref, it is supposed to reference DOM element inside this component, and as we can see, this ref is attached to the element of the type HR, which represents basic horizontal line. And in TypeScript, we have types for every DOM element. And for HR element, the type will be HTML HR element. And just because this ref might not reference any DOM element until this component will be fully rendered on the page, it may also contain value null. So we're going to use union type to cover null type as well. So the next computed property top offset is supposed to return value of the type number. Let's explicitly say so in here. The next function is also going to return type number. And as for this expression, in here we are trying to reference method called getBoundingClientRect on the DOM element. But the thing is that not all DOM elements that parent node property can reference will have the method called getBoundingClientRect, which is why TypeScript highlights such usage. So in our case, instead of using parent node property, we can use parent element, and it is not going to make any difference in our case. And all parent elements are actually going to have getBoundingClientRect method. But of course, before our component will be rendered in the DOM, the parent element will be undefined. So let's prevent calling method getBoundingClientRect on undefined value by using optional chaining operator. And also, since we have specified that this function getTimelineHeight will return number at the end, let's use fallback in here, and if left side of this expression will return undefined or null, we're going to fall back to 0. This way we ensure that this function will always return numeric value. Next, I'd like to point your attention at another constant which is defined inside TimelineItems.ts module, which is TimelineItemRefs. This is also template ref, which is going to reference some of the DOM elements of some component. And let's see where this constant is currently used. So as we can see, it is used inside the timeline component, specifically to reference timeline item components. And just because here we're also using v-for directive, that means timeline item refs constant is going to reference array of timeline item components, because after executing v-for directive we're gonna get several timeline item components rendered. And whenever we are using template refs on components instead of basic DOM elements, Vue has a special type that we can use to type such refs. The type is called component public instance. And of course we also have to use null value in here, because until component will be rendered in the DOM, this template ref will not reference any element. And in our specific case we also have to use square brackets to indicate that our timeline item refs is going to point to many Vue components. This type should be imported from the Vue library. And let's also add a keyword type in front of this type here. The other thing which is also related to usage of timeline item refs constant inside of this scroll to our function, and the reason TypeScript complains in here is because by the time when this function scroll to our will run, timeline item refs might not reference any DOM elements, so it can be null. And to prevent referencing properties on the null or undefined value, we need to ensure that the first part of this ternary expression will be executed instead. So we're going to add OR in here and check if timeline item refs.value will be falsy value. We're going to execute the first part of this expression to prevent referencing any properties on the null value. Also, we have to find a proper type for this constant EL. So in here we're seeing that the first part of this ternary expression is going to return body DOM element. And for the body DOM element, TypeScript has type called HTML body element. Let's use this type in here. And also we have to determine what type of the element will be when the second part of this ternary expression will be executed. And for this, we have to go inside that component where this timeline item refs is used, which is inside timeline item component. So it is actually used directly on top of timeline item component. Now we have to find out what root element is contained inside timeline item component. As we can see in here, the root element is a li element. So let's switch back to TimelineItems.ts file. And as the second type of the element this ternary expression will return, we're going to use HTML li element. So we're using union of two different types of DOM elements in here, HTML body element as well as HTML li element. And this way we are covering all types of values this ternary expression might produce. Now I would like to click around in the application a little bit to ensure that after all recent modification we haven't broken our application. As we can see so far it looks good, so let's switch back in the editor and take a look at another thing inside the TimelineIndicator component. Earlier we have specified the type for indicator ref as a union of types HTML element and null. But if we will actually take a look at the type of this indicator ref variable now, we're gonna see that it uses a union of three different types instead of union of two types, just like we have specified. And the reason to that is because we have not specified any initial value for this constant, which is why as initial value it uses undefined. So to fix this problem, we just have to specify initial value as null. And now we're gonna see a union of two types. With that, we're finishing this lesson. As always, link to the source code will be in the description. Let's keep going with our view components. There is not many left until we fully type all view components in our application. And the next component will be TimelineHour component. If we'll take a look in the browser, we will see that TimelineHour component is used inside TimelineItem component. And it is actually responsible for showing individual hours of the day. So as we can see, it's pretty simple component. And as it usually goes, we'll start typing this component from specifying types for props. This component accepts only one property with the name hour. Also, we were using validation function for this prop called isHourValid. Let's take a look at the definition of this function inside Validators.ts module. In here, we were ensuring that the value of the hour should be a number, and at the same time, it should be the value from 0 to 23. So it should represent an hour of the day. But just because we're using TypeScript now, we don't have to use this validation function anymore, because if we're going to properly type the prop, we will get all necessary guarantees automatically. So I'm actually going to specify the type for the hour property as custom type called hour. This type does not exist yet. So now let's switch over to the file where we define all custom types. It is types.ts. And right here, I'm going to export the new type with the name of hour, which is going to represent all hours in a day. So basically, it is going to be a union of several numbers, starting from 0 and ending at 23. Now we can return to TimelineHour component and import this newly created type hour. As always, let's use keyword type while importing this type hour and reorder import statements. There is actually some other places where we can leverage newly created type hour. For example, if we'll go back inside types.ts, right here we have an interface called TimelineItem, and as for the hour property, currently we're using numeric type. So to be more specific, we can use our new type, which represents an hour. So now the value stored inside our property can only be the number from 0 until 23. Now we can go back to TimelineHour component, get rid of all commented code in here, and continue introducing TypeScript in this component. So the next thing we're gonna do is specify the type for the return value of this computed property. It will be array of strings. And as for this error, TypeScript complains that we are passing numeric value as a second argument inside pet_start function. But this function accepts either string or undefined as a second argument. So I'm basically going to convert this number into string. And now everything seems to be okay in this component. But we still can improve a couple of things inside TimelineItems.ts file. So right here, if we'll take a look at scroll to hour function, as the first argument, it accepts an hour, which is currently of numeric type. But to be more specific, let's use our new hour type. Right after this, we're getting an error inside another function scroll to current hour, and this error occurs because getHours method returns value of the type number. But we have actually specified that scroll to hour function as the first parameter should take value of type hour, since we are sure that getHours function is going to return the number from 0 to 23, which is completely compatible with our type. We can explicitly cast this type to hour like so. And now the error is gone. But there is also a similar error which exists inside the last function generate timeline items. In here, we are trying to assign value of the first argument of disclosure to the property hour of TimelineItem object. But just because first argument of numeric type, we have type mismatch, because our property is of actually our type. So in here, if we'll take a look at this expression, this actually generates array of numbers starting from 0 to 23. But in order to ensure that the closure of the method map is going to accept value of the type hour as the first parameter, we can cast this whole expression to array of hour elements instead of array of numbers. For our case, it is going to work because an hour type is a subtype of a number type. And this way we have fixed all the TypeScript errors. Let's continue working on our project in the next lesson. In this lesson, we're going to finally finish introducing TypeScript into all our view components. So the next component will be TimelineItem component. We have done this so many times, so I'm basically going to do the same steps as always by adding length attribute to the script tag, and then start typing props for this component. It accepts only one prop called TimelineItem, and the type of this prop will be TimelineItem interface. Let's not forget to import this interface. Let's remove unused imports from here, as well as this commented code. And just to remind you how a TimelineItem component looks like in the browser, we can see it on the timeline page. So this component is responsible for rendering individual list elements of our timeline. The next component we're gonna work on will be component called TimelineStopWatch. This component is located inside TimelineItem component, and this one is responsible for showing the stopwatch. The process will be completely the same. I'll open up TimelineStopWatch component in my editor and start with adding attribute length to this script tag, and then I'll extract the definition of the props and assign dynamic type argument. For this define props call, we can actually use the same declaration for props, just like we have used inside TimelineItem component. So I'm gonna copy over this declaration from here and paste it inside TimelineStopWatch component. Let's import the custom TimelineItem type into this component, remove this unused code, and rearrange import statements a bit. And finally, this was the last component from the components folder, but we also have components that are responsible for showing individual pages. They are located inside pages folder. So in our application we have 3 pages and 3 page components to represent each page. And just because page components are usually high-level components that combine other components, there is not much logic present in these components, so it will be pretty easy to introduce TypeScript in these components. I'll just have to add length attribute with the value TS, and it will be enough. Move on to the next page component, the progress. Same thing goes here. I'm going to add attribute length with the value TS, and that's basically it. The next page component is called the timeline. Here I'm gonna follow the same procedure by adding attribute called length and rearrange import statements a little bit. And we almost forgot about one more component in our application. This is the root component called app.view. In this component there is not much to type either, so I'm going to assign attribute length with the value TS, and that will be it. So since we have already introduced TypeScript into all view components, there are several validation functions which are currently unused that we can remove. So I'm gonna open up Validators.ts, go through all these functions and remove those that are not used anymore. Such functions are isTimelineItem valid, as well as isActivity valid. Same goes with isHour function. And if we'll scroll down to the end of this file, we can actually see here we have a couple of functions that are deemed, which indicates that these functions are not used as well. So I'm going to remove all these functions too. And at the top of this file, we can see that some constants are no longer used. We can get rid of them. As we can see, TypeScript has made many of those validation functions no longer necessary anymore. And this is another benefit of using TypeScript, that it allows us to write much less code in many scenarios. So at this point, we'll finish this lesson. Let's continue working on the project in the next one. Let's work on the icons. Primarily we use icons inside buttons, but so far we haven't yet introduced TypeScript into icons module. First of all, let's take a look at one of the examples how we use icons. There is an example of it inside timeline stopwatch component. As we can see, when we're using base icon component, we have to pass prop called name, where we specify an icon we'd like to display. And then inside base icon component, we are using dynamic view component, and based on the passed icon name as a prop, we are extracting icon view component from an icons object that we have imported from an icons module. As you can see inside this icons module, we are importing a bunch of icon components, then create constants to represent every icon's name, and eventually we are creating an object where keys would be icon names and values would be corresponding view components that represent those icons. But what if we are actually going to create a separate enumeration that is going to represent valid icons, instead of storing icon names as a separate constants in here? So let's just write out, I'm going to export new type called icon name inside types.ts, and then based on this set of constants, I'm going to use them as an individual elements of this enumeration. Let's just convert this syntax into valid enumeration type, like so. We also need a comma at the end of each enumeration entry. And now we can use this new icon name type to represent icon names. For example, when we were declaring NavItem interface, we were using type string for an icon property, but now that we have a custom type that represents icons, instead of this string we can use our type icon name, which means that this property icon will only be able to store valid icon names, but not any random string. And now back to icons module, and let's consider one more time this icons object. If I'm going to add any property inside this object, we're not gonna get any TypeScript error, but it would be actually good if TypeScript would inform us that we have used invalid icon name inside this object. So in order to make TypeScript inform us about such cases, we're going to type this constant by using the record type, which is a generic type, which additionally accepts two dynamic arguments. The first argument represents the type of the key of an object. In our case, we're only allowed to use valid icon names, so I'm gonna specify our custom icon name type in here. And as a second argument, which represents type of values inside this object, we're going to use view component type. And now let's import both of these types. And right away we can see that invalid property name is highlighted, so TypeScript now informs us about any invalid properties in this object. And there is even more. If we'll by accident miss any of the icons in this object, we're also going to get an error because it's necessary to provide all the icon names inside this object that are actually listed inside icon name enumeration. Now let's just specify keyword type inside import statement for the component type right here. And at this point we can actually get rid of all these individual constant declaration that represent icon names, because we are using enumeration where all icon names are grouped. So instead of using constants as keys for this object, we're going to use enumeration icon name and reference individual elements of this enumeration. The end result will be the same, but now we actually use more appropriate type where all valid icon names are grouped. So the next thing we need to do is actually replace all icon name constants that are used inside view components to use enumeration icon name. For example, inside ActivityItem component, instead of using icon trash constant, we're going to reference icon name enumeration and use specific icon name in here, but without using icon prefix. And then let's not forget and remove unused constant icon trash, rearrange these import statements a little bit, and move on to the next component. We haven't yet introduced TypeScript inside BaseIcon component, so let's do it just yet right now. I'm going to add length attribute with a value@ts, and let's properly type props of this component. So this component accepts one property called name, which will be valid icon name. So in our case, we can use our custom type icon name right here that we have created earlier. And as for the validation function isIconValid, we no longer need to use this function, so I'm gonna go inside Validators.ts and get rid of this function from here. And also let's remove this unused import. Let's get back to BaseIcon component and remove all commented code. Let's also add type keyword inside this import and move on to the next component, BaseSelect. Inside of this component, we're using one icon with a name iconXMark. So I'm going to convert this usage to use our newly created type icon name and reference icon with a name mark. And then let's scroll up and remove this unused import of the constant and move on to the next component. The next one will be the activity form. In here, we also have one icon that we need to convert to use icon name enumeration. And then also let's remove this unused import of constant. The next component will be the header progress component. In here, let's search for an icon, check circle, use our new enumeration icon name, reference an icon with a name check circle, and remove unused import of the old constant. Identical steps we're going to do inside the next component, which is the logo component. I'm going to use icon name enumeration and reference icon with a name clock, and then I'll scroll up and remove unused import of this constant. We're doing pretty much same steps with all view components, where we're using icons. And finally, we are left with only one component where we still have to use icon name enumeration instead of icon name constants, which is timeline stopwatch component. So I'm going to do this conversion in here 3 times by using icon name enumeration and referencing corresponding icon names. And finally, we can scroll up and remove this import of 3 unused constants. Now that we have done converting all view components, there is also one more file where we are using icon names. This file is called constants.ts. So in here, I'm going to use icon name enumeration to reference corresponding icons instead of using icon name constants in all of these places. And right after that, we can remove the import of unused constants. And this way, by introducing new type which represents valid icon names, we were able to improve our code just a little bit. So now let's open up the browser and click around a little bit in our application to make sure that after all our recent changes, we haven't actually broken our application. As we can see, so far so good. Application works as expected. So let's continue development in the next lesson. In this lesson, I suggest we refactor code in such a way that we will no longer need validator functions. So we will be able to completely remove this validators.ts module at the end of this lesson. So let's go through these validation functions one by one, see where each one is used, and try to refactor our code in such a way that we will no longer need these validation functions. Let's start with the first one, isPageValid. As we can see, this function is used only once inside router.ts, specifically inside normalize page hash function. So in order to get rid of this function, I'm going to copy the function body and inline it on this place. So this way we can remove isPageValid function. First of all, let's just import constant NavItems inside this module, scroll up and remove unused import of isPageValid function. And finally, let's go back to validators.ts module and actually remove definition of this isPageValid function. Now let's actually continue doing these steps with the second validation function is undefined or null. If we'll take a look and find where this function is currently used, we'll see that it is used also in only one place, specifically inside BaseSelect component. For this, computed property is not selected. This property is used as a value for an attribute selected on this options element. But we can actually compare the value of the selected prop with a null, and this way we're gonna get the same result. So there is no need to actually use that computed property. We can get rid of this property, and this way isUndefined or null function is no longer used at all. By the way, now that we don't reference props inside the script block of this component, we don't actually have to assign props object to the constant, because since we are only referencing props inside the template, view allows us to access those props from within template without actually assigning props object to any variables. So now we just have to get rid of any unused imports inside this component, and I also prefer to keep all my imports of types at the very end of the import statements. So I'm gonna move this statement to the bottom. And now let's go back to Validators.ts and remove isUndefined or null function. As we can see, isUndefined function has become dimmed. That means it is no longer used as well, so we can also remove this one. There is one more function, isNull. Let's find out where this function is used. Thankfully, there is also only one place where we are referencing this function, specifically inside of functions.ts module. So this function is pretty simple, and we can inline body of this function directly in here by comparing value with null like this. So this way we can get rid of isNull function, and now that this file is completely empty, we can fully remove it. And just like that, thankfully to TypeScript, we were able to remove all validation functions in our application. And as we can see, application works as expected. We don't see any errors, so it's time to move on to the next lesson. In this lesson, we're going to do a little refactoring and change the representation of one type, specifically type called PageName, because as we can see currently this type is a union of 3 different types. But what if instead of using a union type, we could actually represent this type as an enumeration with 3 entries? So let's do just that. I'm going to create new type PageName, which in this case will be an enumeration, and then I'm going to list all the entries inside these enumerations, which will be our valid page names in our application. So the page names are timeline, activities, as well as progress. Let's also make all these values uppercased. And by actually doing this conversion, we can get rid of these 3 unused constants, and then we can open up constants.ts and completely remove declarations of those constants, because now they will not be used. Instead, we're gonna use our new page name enumeration to reference page names. And we are going to do it like this. Instead of using constants right here, let's reference page name enumeration and then refer to individual elements. In the first case, it will be timeline page. In this case, it will be activities. And lastly, here we're gonna use progress page. Moving on to the next module where we need to do the same replacement inside router.ts. Specifically inside of this routes declaration, let's use our newly created enumeration page name instead of using individual constants. In addition, there are also a couple of mentions of the old constant page name at the very bottom of this file, so we're gonna have to convert these 2 places in the same way by using page name enumeration. And finally, at the top of this file, we don't actually need this import of constants. We can remove this import. And then what we also can do in here is to actually combine imports of ref as well as type component into one import statement, like this. So let's continue using page name enumeration instead of individual page name constants inside view components. In here we need to replace page timeline constant with our new enumeration page name. Let's remove an import of unused page timeline constant and move an import of the type to the end of this list. Inside the header progress component, we're using another constant page progress. So in here we have to do the same change by using our new enumeration page name instead of individual constant. As always, let's remove unused import of page progress constant. Next one, the logo component. Right here we can see that we are using page timeline constant a couple of times. Actually, we're using it 3 times in here. So I'm going to do the same replacement 3 times and eventually get rid of an import of page timeline constant from here. And just to make sure that we haven't broken our navigation in the application, I'm going to click around and navigate to different pages. As we can see, navigation works as expected. So in this lesson we have refactored the code in such a way that now we use more appropriate time to represent valid page names, which is an enumeration, instead of using basic union type as we were doing before. Let's continue working on the refactoring, and just like we have done in the previous lesson where we converted page name type into enumeration, we're gonna do the same but with ButtonType in this case. So I'm going to create new enumeration and call it ButtonType. In here I'm going to use 5 different button types by basically converting this syntax of a union into individual enumeration entries. There will be nothing different. We're still going to have 5 different button types: primary, success, warning, neutral, and the last one is danger. There is no need to import these button type constants in this file. I'm going to get rid of this import statement, and if we'll go inside constants.ts and take a look at the definition of button types array, before we were using individual button type constants, but now that we are gonna use enumeration, I'm going to change all these usages and reference individual button types by using our new enumeration button type. So now we can remove definition of these 5 constants. There is no need to use them. We're gonna use button type enumeration everywhere where we're gonna have to use button. So we'll have to go through any view components and find all button type constant usages and replace those usages with button type enumeration, just like in here. We're going to replace button type danger constant with button type enumeration and reference danger type. So we can remove this import and move on to the next component, where we're gonna repeat the same procedure. Actually, the next component is BaseButton, which represents all buttons in our application. In here we are importing all button types. There is no need to do it anymore. I'm going to replace all these constants with button type enumeration, just like that. And please note that we can't actually use keyword type in order to type button type enumeration, because in this component we're using button type not as a type but as a value, because we are using individual enumeration entries as keys for type classes object. If we'll scroll down further, we'll see that there is one more button type constant using here. I'm going to replace this constant with button type enumeration as usual. Also, we're using one button inside BaseSelect component. Let's replace this usage with button type enumeration and reference neutral type. And then up at the top, I'm going to remove this unused import. And finally, we have to handle one more component where we use most of the buttons, that is timeline stopwatch component. Here we're using 3 buttons. So in all of these places, I'm going to use button type enumeration. And eventually, we can remove this import of 3 unused constants. As always, just to be sure that we haven't broken our application, I'm going to take a look how our buttons render. As you can see, all buttons look good. We can continue in the next lesson. We're slowly approaching the end of this series, so in this lesson let's just replace all usages of any type with more specific types because it's recommended to avoid any type as much as possible. So let's start with the functions.ts. In this file, as we can see, we're using an AnyType for the first parameter of the normalized select value function, as well as for the return value. And in order to replace this AnyType with more specific type, we have to find where we use this function normalized select value. We're doing it inside BaseSelect component. And as we can see in here, we're passing either string or null into this function, so it makes sense to use string or null union type instead of any type right here. So I'm going to use a union of two types, string and null. And now that we have typed the first parameter of this function, now we have an error related to isNone function because this function accepts number as the first parameter. So in order to fix this issue, we have to explicitly cast value param into number like so. And the whole point of this function is to actually convert values into numbers. So to properly choose type for the return value of this function, we have to consider this ternary expression. And as we can see, if the first part of this expression executes, we're going to get either string or null value. But if the second part of the expression executes, we're going to get a numeric value because second part of this expression converts values into numbers by using this plus sign right here. So eventually this function can return a value of three different types, whether it will be number, string, or null type. So now that we have properly chosen types for this function, let's get back to BaseSelect component and fix the new issue, which we've got after typing normalized select value function. Because earlier we have specified that this function can either return string, number, or null, but payload for this select event that is fired from this component can be either of generic type t or null. So I'm going to explicitly cast this value to one of these types, like so, by using union type. And now everything is fine in here. Moving on and switch over to a different file, time.ts. As you can see in here, we're converting values stored inside of now reactive variable into any type, because without doing this, TypeScript is actually going to complain, because here we're trying to apply subtraction operation to different values. Reactive variable now stores an object which represents current date, and computed property in midnight stores amount of milliseconds. So we are operating in here with two different types. And in order to fix this issue, I'm basically going to call getTime method on the date object to get the representation of this date in milliseconds. And now the issue is gone because both operands of this expression are numbers. And exactly the same procedure we're going to follow inside TimelineItems.ts module. Right here, we're doing subtraction in a couple more places. So in order to avoid using any type right here, I'm going to call getTime method on all these date objects to avoid any kind of errors. And I'm going to do so in both places that are doing subtraction operation, like so. Next one, let's scroll a little bit up and consider syncIdleSeconds function. So right here, after we remove this conversion into any type, we're going to get an error because active TimelineItem property might not have any value, so TypeScript is actually trying to protect us from working with undefined values. So to avoid any kind of errors, I'm going to add a check in here to verify if active TimelineItem computed property actually contains any value. And if not, we're basically going to finish execution of this function by returning an empty value. And just to verify that we're going to get an error without this check, I'm going to comment it out for now. And right away we can see that TypeScript highlights a couple places. So this check is actually necessary to have in here. Let's move on. The similar fix we're going to do inside TimelineItem timer module inside this startTimelineItem timer function. In here, we are trying to reference TimelineItem variable, which might not have any value as well. So before referencing this variable, I'm going to add a check which is going to verify if we're going to proceed further. That means TimelineItem variable contains value. But additionally in here, we also have to include the same check. Inside this closure, we are passing inside setInterval function. And we're gonna have to apply the same fix in one more place inside stopTimelineItemTimer function. So let's also use if conditional and verify that ActivityItem actually contains value before proceeding further. Otherwise, we're going to finish this function execution. And with that, we have finished replacing all usages of any type across our application, which is a good thing because, as was mentioned before, the more we avoid using any type, the better. So at the end, I'm going to switch over to the browser and click around a little bit in our application just to make sure that we haven't caused any errors by doing all those changes. As we can see, so far application works good. Let's continue development in the next lesson. This will be the last lesson of this series, because we have already converted all Vue components into TypeScript, as well as all JavaScript modules. So now the only thing I would like to do in this project is to actually convert configuration file vite.config.ts into TypeScript file. So let's rename an extension of this file on TS. And after we're gonna do so, we're gonna get a few errors. So let's fix them one by one. The first one is related to absence of type declarations for node modules. So in order to fix this issue, we actually have to install type definitions for Node.js. I'm going to switch over to the terminal and run npm install with a flag d, because the library we're going to install will be needed only for development. So the package we need to install to include type definitions for Node in our application is called types/node. And now let's switch back to vite.config.ts and consider the next error. This error is related to meta object, which is only available when we're using ECMAScript modules. So we need to tell TypeScript compiler to treat this configuration file as ECMAScript module. And we can do this in the following way. I'm basically going to add another key inside ts.config.json, which is called module, with the value ESNext, like this. So now everything should be okay and TypeScript should stop complaining. But as we can see, we still have the first error. That is because we need to restart VS Code. I'm going to use command delete and run the command called reload window. And as we can see, after restarting the editor, the error is gone. So now I'm going to switch to my terminal and run npm run dev to make sure that we can still start development server with no issues. As we can see, it works fine. And let's also try to build our project by running npm run build and see if TypeScript is going to be compiled successfully. And as we can see, we got one unexpected error related to type mismatch inside TimelineItem module. So let's switch over to that module and see what is going on there. And the issue here is that we have earlier typed that TimelineItem reactive variable should store value whether number or null, but setInterval function actually returns value of a different type. And to fix this type mismatch, we just need to change this type we have chosen for TimelineItem variable, which will be compatible with the type that setInterval function returns. As we can see, it returns value of the type Node.js.timeout. So I'm going to specify exactly this type as part of this union right here. And this way, the issue is fixed. And if we'll try to rebuild our project by running npm run build in our terminal once again, this time the project was built successfully. So let's also see how our built version of the project looks like in the browser. I'm going to run npm run preview to launch build project in the browser. Switch over to Firefox and click around a little bit to make sure that the built version of the project also works as intended. So looks like everything is working fine. And also one more thing that I have noticed recently is that inside constants.ts we have a constant called button types, which is actually unused, so no need to keep this constant around anymore. I'm going to get rid of it. Same goes with an import of button type inside this module. We no longer need this import, I'm gonna remove it. And now let's build the project one more time, since we have changed source code, just to verify if everything builds properly. So everything looks good, and at the end, I'm going to deploy this project by using search utility, and the process of deploying projects by using search utility was shown in another video, link to which I'm going to leave in this video description. So for now, I'm going to run search utility and specify which folder we need to deploy. The folder with our build project is called dist. So I'm going to run this command, and then in here I'm going to specify my custom domain name, where I'd like this project to be available online. And right after this command finishes, we can open up the browser by using this address, and here we go, we see our project was deployed. And with that we're finishing this series. We have fully converted Vue.js project to use TypeScript. Link to the final version of this project will be in the video description.